the next thing we have on the agenda is a break. So we have a little bit of time.
Caleb, can you hear me?
I can hear you. Yep.
I joined on my iPhone, so I can race through this real quick if you don't.
Yeah, we're still on the same slide that you.
I can see it.
That you were on. Okay, great. Yeah, no worries. It's all good. I think we have critical mass now.
So what I wanted to finish about this slide is that this was an example of using survey data to deconflict the risks associated with designating wind energy areas that BOEM used in the Western Gulf of Mexico. Long story short, the wind energy areas that were designated were essentially sited in the cold spots, areas where there was less mottled bird abundance. So this was a direct application of the survey data. Next slide. Another instance of using data from the Gulf of Mexico on marine birds was during the species status assessment for black-capped petrel. Somewhat surprisingly, we found that black-capped petrel was a rather uncommon, but nevertheless regular resident, particularly in the eastern Gulf of Mexico and somewhat in the central Gulf of Mexico. And that was not understood prior to the new surveys conducted in the Gulf. This paper, lead author with Pat Jodis, was published in Endangered Species Research some time ago. Next slide. Another application is assessing or evaluating seabird exposure to chronic oil spill vulnerabilities in the Gulf. This slide depicts the extent of oil and gas platforms, mostly in the central and western Gulf of Mexico, and a paper that appeared in Frontiers of Marine Science a couple years back illustrates this relative vulnerability assessment across different species of birds. Basically, again, overlapping their distribution with this hydrocarbon footprint to get a sense of relative risk. Next slide. One species that was particularly hard hit by the Deepwater Horizon oil spill was black tern. Several hundred individuals were found oiled during the spill period. A couple of restoration activities have been directed at this marine bird. One is conservation easements on both grasslands and wetlands in the Dakotas. We summarized the highly concentrated nature of black terns in the Gulf of Mexico in a paper that appeared some time ago in, I believe that's Wilson Bulletin. I can't read on my iPhone. Again, this is an example of the marine aspect sort of supplementing the terrestrial-based restoration activities for one of the species harmed by the spill using the vessel data. Next slide. Another surprise, I think, to us was the extent to which the Gulf seabird community is dominated by aerial species. Essentially, 17 of the top species are all aerial in their behavior, which means that when it comes to offshore wind energy, that poses some special challenges. It may buffer them from some risks from oil spills, but it nevertheless creates an interesting challenge on research for evaluating their vulnerability to wind. We've summarized some of the community aspects and assemblage aspects of seabirds in this paper that appeared in PLOS 1. Next slide. Some papers that are forthcoming, they're in press and will appear soon. In fisheries oceanography, we have a paper coming out on flying fish habitat in the Gulf of Mexico. We have one of the largest data sets ever collected on flying fish, collected off 2 survey programs and consisting of several tens of thousands of miles of surveys for them as well. We found this will appear in fisheries oceanography in one of the forthcoming editions, and it looks at the role that flying fish play in co-predator assemblages between seabirds and large tuna. We also have a paper coming out that is the first update on the status of all Gulf marine and water birds made since the Clapp et al. Reports that came out almost a half century ago. That paper will appear in a forthcoming issue of Marine Ornithology. We're happy to share that now because I know many of you are working on vulnerability or risks assessments for Gulf seabirds, and we can share that. Just reach out to me anytime. We've also found that there are some range incursions or expansions going on in the Gulf of Mexico, particularly among the tropical sulids. This summer, we had our first record ever of Nazca booby in the Gulf of Mexico. It's endemic to the tropical Pacific. Next slide. Some forthcoming works or analyses that we will be working on is looking at, first of all, just the descriptive flight height profiles for the more common or abundant marine birds in the Gulf, again, relying on the vessel data for that. The first stage of this analysis will be in a project funded by the U.S. Fish and Wildlife Service, the Migratory Bird Branch. Later on, in a year or two, we expect to switch over to modeling flight height according to wind speed to get a better idea of the interactions that might occur between marine birds and operating wind turbines. Next slide. And we're also interested in some of what we think are changes undergoing like elsewhere in the Atlantic and the Gulf of Mexico. We really don't have a good explanation for why the tropical sulids have exploded. And I mean that literally. In the 1990s, the surveys that were done for marine birds in the Gulf of Mexico failed to record a single brown booby, not one. During the natural resource damage assessment in 2010 and 11, we recorded a handful, but not many. But beginning in the GOMAPS survey and then in the most recently completed surveys, we find that it's one of the most widely distributed and abundant seabirds now in the Gulf. It's not unusual for us to see 10 or 15 at a time accompanying the vessel chasing flying fish. Next slide. I want to thank the massive amount of support that these programs have received from everyone, the Fish and Wildlife Service, NOAA, USGS, Clemson, and especially the Deepwater Horizon Trustee Implementation Group for Open Ocean. Randy Wilson, Pat Jodis, and the staff, the chief scientists, especially for the NOAA ships, have really helped us in this, all three programs. And there are several other people there highlighted with program support and the many seabird observers as well. Next slide. Lastly, if you have any questions, you can reach out to me or Pam for more information. And thanks.
Great, and we do have a few minutes for questions, so feel free to ask away. We have 2 to 4 minutes. Must say it's an incredibly impressive abundance of research that you all are doing, and we're so happy you are willing to share with everyone here.
Our pleasure. Sorry for the technical malfunctions.
Oh, no worries.
That's not at all your
Ian,
fault.
Yeah, it really isn't, especially the last one. Ian asked if brown boobies have rejigged their energy budget by riding ships, perhaps.
That's a good question. I was recently talking to Dave Perextra in Boehm about they have a similar thing going on in the Pacific coast off Southern California, boobies expanding. The difference there is there are islands in which some of the colonies have, the boobies have started new colonies on islands where they weren't before. we simply can't trace the origin of all the birds we're seeing in the Gulf of Mexico. We don't have a place to point in the Caribbean or the southern Gulf of Mexico or Quezal Bank off of northern Cuba. It's not a slam dunk as to where the birds are coming from, but we also don't have any evidence elsewhere of a sort of a population increase. So it does beg the question. It may be the case that they've simply learned a new behavior and that has rapidly transmitted in the species, and it's allowed them to exploit a notion that otherwise they may not be able to use. Certainly, the Gulf has massive quantities of flying fish, and they've become all three tropical species have become very adept at following ships to get those fish.
My interest in this is because brown booby seems to be an increasing bird in the relatively cool waters off Atlantic Canada, including even Newfoundland. And I'm just wondering, like, maybe they've just found a platform where they can sit, expending relatively low amounts of energy while they're foraging. So it's completely redesign, their whole ecology.
Yeah, and I think that's kind of where that's the lean that I have about what's happening. It'd be easy to wave one's arms and say it's climate change or something, but the Gulf is warm year round, and I'm sure it has warmer and cooler years, but we don't have any real good climate change explanation for the birds' increase either. So it may be possible that they've just learned to both use ships for resting and foraging, and basically it opens up new frontiers for them.
There's just one comment from Evan, Chris, letting you know that he would be interested in talking flight height stuff with you headed down the road. He's been working through various issues with that data and would be happy to collaborate. But I think we need to head to a quick break. We'll just take a quick 8-minute break. Sorry for all the technical issues. I really appreciate everyone working with us on that. And everyone, if you can be back a little bit before 2:30, so we can start next session, that would be great.
Thanks so much, Chris and Greg, for great presentations. Sorry for the technical problems on our end.
You're welcome. Thank you for the opportunity.
Yes, and please, everyone, put any additional questions you might have in the chat for both Chris and Greg, and we can make sure it gets to them.
Yeah, I don't have chat function, so you'll need to somehow get it to me another way.
Yeah, and I was going to say, I know it's a little bit late now, but I just responded to an email, Chris. I was able to reach our IT person, and they said to give them a call. There's a phone number in there to try and figure out how to get you back up and running in Teams.
All right, thanks, Caleb.
Yep.
So this will probably happen again tomorrow. But what can you do?
Let's hope not. But this is just another way that Fish and Wildlife Service is trying to save money.
Excellent.
Yes, getting us a license that only allows us a certain length of call on Teams. So there you go.
Hey Caleb, I noticed on my screen that it looked like the meeting had been going on for like 28 hours or something like that in the tracker. And so it might have just been like left on overnight or something, and maybe that's what happened. I'm not sure though.
Well, I disconnected, and I am the meeting organizer, so it shouldn't have been going on when I sign
Yeah.
off. But we can just
I
make
believe
sure
that is what should have happened, but I'm not sure it did for whatever reason. I
we
don't
can
know.
make sure that you just remind everyone to log off tonight in case that's what
Because I
happens.
remember glancing
What
at that
happened.
this morning and being like, wow, this meeting's been like on nonstop for like over a day now.
You weren't on the 2 a.m. session. It was really pretty great.
Not this
We
time,
can
not
kick
this
out
time.
this. We can kick out the straggler tonight just in case.
Yeah, maybe we
Yeah.
can just disconnect everybody. I don't know. Anyway.
Yeah, I
totally.
mean, Caleb, yesterday when Linda signed out of the forage fish and ska working group meeting, I was able to stay on. I just like recorded chat stuff. So it didn't
So
stop
maybe
and
maybe that's what happened.
she set up the link. So yeah, who
Mhm.
knows?
I will say though, if it's showing 18 minutes right now, so 30 hours from now will be well done tomorrow. So it should be fine.
Good point.
Unless
Yeah,
we
oh my
go until
God.
like 8 p.m.
Yeah,
That's
hopefully
crazy.
some good luck gets us going all the way through the end of the day tomorrow. So
I think the storms are just as much of an issue, unfortunately.
maybe. It's certainly raining plenty up here.
Yeah, looking at my radar, literally the entire eastern seaboard is storming.
Yeah, I wish it was snowing, but we're just getting a bunch of crap.
So hey, Caleb and Allison, I'm gonna have to scooch to another agency meeting, but I'll try to sign them back on later. But thank you so much. You guys did such a great job.
Thank you, Ruth. Really
Yeah,
appreciate
thank
it.
you for your input. Been great.
Oh, yeah.
Hopefully you can make it back before too long.
Yeah, I'm gonna try.
Did the fun stuff.
All right.
Okay.
See ya.
Hey, Caleb, this is Doug Forcell.
Hey,
Yeah,
Doug, how you
it
doing?
was last night because at about midnight, I was trying to get my pictures to work. And I noticed Josh Adams was still signed in at 3 a.m. your time.
Okay. Maybe
But,
that's it, is
I was
permanently
going to
signed
say,
in.
I think I finally figured out enough muting to get those notifications, but they're very distracting. People are having conversations about the previous talk, and they just keep flashing up and beeping. And maybe just remind people to go to a private chat if they want to talk about something.
Yeah, I think there might be a way to turn off.
I did.
you-
I
You
have.
can
There's
hit,
two different
you,
ones,
yeah, you can go through settings and then there's a mute notifications.
and I finally got it, but it's
Yeah.
a real pain to constantly
Okay.
have those pop. Yeah.
Unfortunately, there's no other chat room.
Yeah,
Well, you
Teams
can't-
is not like that, like Zoom for that, unfortunately.
Oh, you can't do individual
No.
chat.
Well, we
No.
can, but only within our agency mostly.
Oh. So, but it makes it very distracting. There must have been 100 of them going on one of those talks, and or maybe just tell people to wait if they're talking to somebody else about a different paper.
Yeah.
That's a tough one.
Yeah.
Yeah, we could, I mean, we could just also let everyone know how to mute notifications so it doesn't bug them.
Yeah. well, it would be good, there are a few that you want to see, but if you have
Right.
to mute everything and get rid of everything, then
I see what you mean. Yep.
yeah.
All right,
And I'm
well,
not-
let's get this started back up. Sorry to cut you off, Doug.
Yeah, no, I was gonna,
All right. Thank you everyone for dealing with our issues once again. Thank you for all the amazing speakers. And we are gonna move on to offshore wind science and mitigation with Kate Williams as the session lead.
Great, thanks, Allison. Let me share my screen here, hopefully successfully, given the number of issues we have had recently. What is
And
it saying?
You're frozen currently.
It's not letting me select. Oh, this is great. This is a great start to the next session.
I do
no.
have your slides available and I'm happy to them for you.
Can you see that?
I wonder if your internet is, because you're frozen right now, Kate. I wonder if it's hung up.
Can you hear me?
I can hear you.
Yes,
Okay,
we can
yeah.
hear you. Maybe you can
Uh-huh.
turn off your video.
Yeah.
Yeah, I mean, we have other people at the BRI office, and it seems like things are working. Maybe Kate should restart
Okay.
real quick.
Yeah.
Are you seeing my slides?
Oh no, definitely not.
Nope.
Not yet.
For goodness sake. Okay.
And again, we have, I think Allison has your slides saved if you want to
Yeah,
do
they're
that.
slightly outdated, but we could do that
Okay.
if that would be easier.
Okay, sorry about that.
All right, let me, I guess, stop sharing. I'm seeing it as if I am sharing, but all right, I'm gonna have to restart, I think, because nothing appears to be working. So
Okay.
I will be back in a minute. Sorry about that. If we could maybe
We'll
switch to.
Yeah.
Perfect.
Does it make
Thank you.
Does it make sense for us to swap and I can go first?
Yeah,
Julia, if
that'd
you're
be
able
great,
to,
Julia.
Okay. Yep,
to
sure
jump in
thing.
there.
Let me, I'm at the same office, so let's see if this works.
It's already looking better. We can
Okay.
see something.
You can
Yep,
see
I
our,
can see
can you
it.
see our
Yep,
screen?
you're good.
Okay.
You're good. I think maybe all the presenters, maybe you should try restarting right now. Don't miss this talk, but in between, please maybe try doing that. Okay, go ahead.
All right. Sounds good. So my name is Juliet Gulka. I'm a marine biologist, quantitative ecologist at the Biodiversity Research Institute. And I'm going to be talking today about a project that we've been doing with Environment and Climate Change Canada to look at existing evidence for mitigating impacts to birds and bats from offshore wind development. So as offshore wind development continues to grow in the US, we really need to try to balance our need for renewable energy with potential effects to wildlife, including birds and bats, and try to work to avoid, minimize, and compensate for those effects. And while we can gain understanding of these effects from areas like Europe, where offshore wind development is a well-established industry, there remains a lot of uncertainty around the potential effects and the mechanisms driving these effects. And so really, in the face of this uncertainty, we want to consider how best to mitigate these effects. And mitigation of effects such as those posed to birds and bats by offshore wind development is guided by the mitigation hierarchy, which many of you may be familiar with. And that has kind of three main components. The first is avoidance, and then minimization, and finally compensation. And so given this framework, I'll be kind of using mitigation to refer to all of these steps in the mitigation hierarchy. So avoidance is the first priority at the top of the hierarchy. The best strategy for dealing with anthropogenic impacts is to avoid those impacts altogether. Subsequent steps then occur in descending order of priority. such that effects that cannot be avoided should be minimized. Minimization primarily occurs during pre-construction and operations in the case of offshore wind, and includes things like design decisions, as well as operational parameters. And then for effects that can't be avoided or minimized, the final step in the mitigation hierarchy is compensation or offsets, whereby activities are employed to improve and enhance impacted populations for which effects cannot be avoided or minimized. And that can either occur on or off-site and may include options such as habitat creation, improvement of existing habitat, things like invasive species removal to try to boost those populations and compensate for the potential environmental impacts. So to get at this, the goal of our project was to review and assess the state of knowledge of mitigation methods for aerofauna, so birds and bats in relation to offshore wind development. And so to do this, it included an inventory of the different mitigations that have been proposed for use for offshore wind development across jurisdictions. And we wanted to try to summarize the weight of evidence supporting those approaches in terms of their effectiveness, and identify key knowledge gaps in our understanding and kind of prioritization of future studies to try to examine effectiveness of mitigation options. And so we really wanted to, identify mitigations that could be recommended or required. So we need to identify mitigation measures that actually work. If we're applying these approaches without good scientific evidence, then that they can reduce impacts, that may lead to both wasted resources and also kind of false assurance that the effects of offshore wind development are being appropriately mitigated. So to do this, we utilize an existing resource, the Mitigation Practices Database tool that was developed by the New York State Energy Research and Development Authority and published in 2019. And this is an online filterable tool that draws from a literature review of practices about mitigation impacts of offshore wind development on both fisheries and wildlife. And so from this, we extracted those specific to birds and bats, which included 109 peer-reviewed and gray literature sources. We then conducted an update of the literature review to include newer sources from 2019 to 2023, focused on birds and bats, using both Google Scholar and the TETHIS knowledge base. And from that, we added an additional 78 sources. And from various sources, following the kind of existing format of the MPD tool, we extracted information around the mitigation approach itself, the relevant taxa, types of stressors and effects it's aimed to address, the industry that it came from. While the focus was offshore wind, we also included sources from the terrestrial wind industry, oil and gas, and other relevant industries, as well as the level of testing and implementation and evidence of effectiveness of the mitigation strategy, and kind of synthesized across all of those sources to combine similar approaches. And so this overall resulted in 212 distinct mitigation approaches for birds and bats that focused on a range of stressors, potential effects, and drew from various industries. A majority of those approaches fell within the minimization category of the mitigation hierarchy, with fewer for avoidance and compensation. And then more than half of the approaches were focused on birds, as well as kind of a quarter focused on bats and a quarter focused on birds and bats combined. And information came from various industries, a lot of which coming from the terrestrial wind industry, 66% of approaches, while 45% came from offshore environments, including offshore wind, oil and gas, and other maritime industries. So diving a bit deeper into the types of mitigation measures included, we split those minimization approaches into 6 categories that included configuration of structures, so things like turbine layout, operational parameters. That includes curtailment, which is common in the terrestrial wind industry, as well as visibility and detectability parameters. So that includes things like painting turbine blades to make them more visible, or in some cases, using lighting to increase detectability. But then there were also measures focused on lighting that was more around reducing lighting and altering light characteristics to reduce potential for attraction, as well as a category on deterrence. And then finally, some mitigation approaches related to vessel operational parameters and water quality. So here's kind of a summary of the effectiveness across those categories. So they're grouped into 4 categories, whether the approach was not implemented or implementation is unknown, whether they were field tested, whether they're actually implemented in the industry and then kind of within that, whether effectiveness was unknown or there was evidence of effectiveness. And so we've got birds on the left, bats on the right, with these various mitigation approaches in those categories that I just went through, with the paler blues and greens indicating mitigation approaches that were field tested or actually implemented to help mitigate the effects of an anthropogenic activity. Pale green are those for which there was some evidence that the mitigation measure actually worked as intended. So for birds, you can see that a lot of the approaches fell within the lighting and deterrent categories, while turbine operational parameters were common for bats. And most mitigation strategies, regardless of category or taxonomic focus, were not implemented nor tested to determine their effectiveness in the literature that we reviewed. So we also wanted to try to kind of summarize, getting a little bit further into detail of the different types of approaches and split out kind of which ones we think there's a reasonable level of evidence, or in some cases are kind of common sense approaches that should be implemented. And those are in green for birds and bats, separated out. And then we have a couple of categories of yellow and orange. Yellow is where there's some evidence of effectiveness, but more research is needed. Maybe it was for a particular circumstance or species. Orange represents conflicting evidence in the literature, so definitely in that case, more research is needed. Red really is that there's either the information is lacking, there's no evidence of effectiveness, or actually evidence of ineffectiveness. And then finally, a couple of gray that were not applicable to one of the 2 groups of interest. So overall, the mitigation approaches that were kind of field tested or implemented, the reviewed literature really indicated evidence of effectiveness in only about 36% of cases for birds. That included approaches related to lighting, things like reducing the amount of lighting, avoiding certain colors like white lights and steady burning lights were most commonly tested and effective for reducing maladaptive attraction and collision risk. For bats, alteration of turbine parameters, particularly curtailment and feathering of turbine blades, were most commonly shown to be effective. This is pretty common in the terrestrial wind industry. And then avoidance of effects, things like carefully siting activities and related measures to avoid effects to wildlife and their habitats, really remains one of the best available options for mitigation at offshore wind facilities, given kind of the lack of evidence of many of the minimization techniques. So minimization was kind of one of the primary areas in this review, but a lot of those approaches have limited evidence of effectiveness. And we recognize that there are challenges associated with testing and evaluating the effectiveness of these mitigation approaches, particularly in the offshore context. Given the harsh and inaccessible nature of offshore environment, it's both challenging and expensive to test mitigation strategies. And there's a lot of, environmental variability in marine environments. And so that's often coupled with low sample sizes for studies that are trying to measure change in these systems, creating challenges in achieving statistical power to provide evidence of effectiveness. Additionally, wildlife species and their habitats may be affected by a range of effects and stressors, and the sensitivity and vulnerability of species varies in relation to a variety of factors, both internal, whether that's demographics or life history, or external, things like the facility layout and the location. And so as a result, many mitigation measures may or may not be effective, and in some cases have already been implemented without the necessary evidence that they're appropriate and effective approaches in the offshore context. And so this can really lead to wasted resources. And again, that potential false assurance that we're actually mitigating for these effects when maybe that's not the case. So given the results of the literature review, we kind of suggest 3 primary categories of short-term research priorities related to mitigation. The first is really to focus on measures that have already been implemented in the offshore wind context and included in, project permits. These include things like minimization through project design, things like the influence of turbine size and air gap. More research is really needed there, as well as things like perching deterrence, which are already being included in permits. Second are measures that have kind of the greatest potential to reduce impacts based on evidence from other industries, but haven't yet been tested in the offshore context. In particular, curtailment is a strategy that's been effectively implemented in the terrestrial wind industry and found to be effective to reduce bat mortality. But we don't really know the degree to which that those findings will transfer to the offshore context, and nor the scale at which bat collisions offshore need to be mitigated. Another example of this is minimizing disturbance via altering vessel parameters that could help reduce potential disturbance to marine birds. And then thirdly, we recommend an immediate focus on mitigation measures that can be tested at individual projects, such as visibility enhancements, things like that. Studies that require comparison across projects with different project designs will require, the construction of multiple projects with different characteristics and really long-term data collection at a regional scale, which is important too. But in the immediate term, we kind of feel that prioritizing well-designed studies at these smaller project scales can really help provide the data for some of those longer-term studies. So very few mitigation measures have been shown to be effective, largely due to lack of testing. Even fewer have been shown to be effective specifically in relation to offshore wind development. Available data suggests that in order for mitigation to be effective, it likely needs to be species and location specific. A measure that works at one site for a given species and life history stage may not be effective in other contexts. And thus, even the measures that were successfully used in, say, the terrestrial context should be tested in relation to offshore wind development and for particular species of interest to help ensure that those can effectively help reduce risk. Since it may be difficult to identify mitigation strategies that are broadly generalizable, an array of mitigation measures should be further explored to provide options for specific scenarios. We also suggest that in the absence of proven on-site mitigation approaches to fully offset effects to birds and bats from offshore wind development, that compensatory mitigation should be explored in the immediate term as well. Potential strategies to consider, should include both on and off-site. Without on-site mitigation measures that have been proven, we really also need to look off-site as well. And there are a range of approaches that have been suggested primarily in the context of other industries that we can pull from. In the case of birds, most has focused on marine birds and includes things related to fisheries, creation and restoration of nesting habitat, things like that. So to conclude, given the current status of available mitigation measures, a sensible approach to mitigation at offshore wind facilities for birds and bats could include kind of universal implementation of a couple of things that have sufficient evidence. But also we really just need a lot more research into the effectiveness of these various strategies. And that's all. Thank you.
Great, thanks, Julia. I think there's a couple questions for you in the chat. Allison, do we have any time to go through those, or should we move on? And
yeah, we have like 30 seconds, so maybe one question.
okay, Julia, if you want to take a look while I'm trying to share my screen again.
Yeah, so there's a question about whether the single black blade strategy has been studied in the offshore wind context. It hasn't yet, but that is something that is definitely of interest because of the evidence that's been coming out in the terrestrial context.
We can see your screen, yay.
Good. I'm going to keep my camera off just in case. I clearly have like a worse computer than Julia does or something, or it's just me, which is also very possible. But Hey everyone, sorry for the snafu, but I'm Kate Williams. I'm with the Biodiversity Research Institute. And I'd like to first acknowledge my co-authors on this talk from NYSERDA Fish and Wildlife Service and Stony Brook University. Today I'm providing brief updates on 3 different projects. They're all focused on developing and sharing good quality data to better understand the effects of offshore wind on marine birds. One of the projects is complete, one is ongoing, and one is just getting started. I don't have time to name everyone who's been involved, but just want to acknowledge that these are all highly collaborative efforts with a lot of contributions from different folks. We owe a huge debt of gratitude to everyone who participated or is participating in these efforts, as well as our funders for these projects, including the New York State Energy Research and Development Authority, BOEM, and the Department of Energy. So if we're trying to develop offshore wind in an environmentally responsible way, we need to better understand its effects to marine birds and how to mitigate them. And you can kind of think of this as a cycle where we're like identifying priority research needs and data gaps, developing some guidance and frameworks for how to do research and risk assessments, actually conducting the research to understand effects, and then using the results of that research to inform adaptive management and mitigation. And throughout this, I would argue that we also need to be engaging and informing stakeholders. So scientific research doesn't happen like independently of society, right? The research gaps we identify, the research we conduct, how we use research results to inform decision making, that's all informed by a public and a political understanding of what the effects of this industry are and what can or should be done to minimize those effects. So if we're going to sort of most effectively improve our understanding of offshore wind effects on marine birds, we need to think about that public and stakeholder engagement aspect. Unfortunately, we can't do our research independently of the rest of society, as appealing as sometimes that might be. So there are ongoing efforts in all 5 of these sort of components, but I'm going to talk today about 3. Development of guidance for research efforts, stakeholder communications, and conducting research to understand effects. So first, stakeholder communications. The Offshore Wind Environmental Technical Working Group, or ETWIG, is a multi-sector working group formed by the state of New York. It's focused on informing environmentally responsible offshore wind development in the US from Maine to North Carolina. And we are just now forming a new specialist committee of the ETWIG. So it will include a few ETWIG members, mostly non-ETWIG members, other folks with relevant expertise, including several AMBC members. And the goal of the committee is to develop communications materials to aid in the dissemination of accurate and sort of readily understandable and science-based information around the potential impacts to birds from offshore wind development. And this is modeled after a similar committee that we still have active right now that's producing an FAQ document on marine mammals and offshore wind. That committee was initiated last year after a lot of sort of misinformation hit the public media in early 2023 about offshore wind causing whale deaths. We haven't had that same kind of sort of public interest in birds and offshore wind, at least not yet, but birds are a perennial topic of interest in relation to offshore wind. And so we're hoping we can produce some nice materials and sort of get out ahead of any misinformation that may be circulated in the future. So the product we're aiming for here is an FAQ document that has multiple levels of response detail. So there's a very detailed, like in-depth response with scientific citations, and then there's sort of a higher level response as well. We also are producing a press packet to help sort of facilitate sharing of FAQ materials. And the audience here is stakeholders interacting with the general public. So it's folks like you all in the AMBC. Like what we're trying to do here is sort of an intermediate step between the original sort of papers and reports and permitting documents and the sort of social media high-level messaging type stuff that organizations might use to communicate with the general public. So we're trying to synthesize and translate scientific data into more accessible summaries to help then inform public communications. So the first committee meeting is next week. For the whales and offshore wind FAQ, we developed quite a robust process for developing the FAQ materials and ensuring accuracy before they're published. So support staff from BRI actually do the research and draft the materials, and then they go through actually 3 rounds of committee review. We're missing one on this graphic, as well as review by a group of volunteer expert reviewers who are external to the committee, and a review by the members of the ETWIG. So it's not a quick process, but it is pretty thorough. And then we publish the FAQ responses in rounds. So every time we have, say 5 to 10 new FAQ responses that have been finalized, we'll push an update to the FAQ online and reach out to folks on our sort of mailing list to share the update. So for the birds and FAQ process, as I mentioned, the first committee meeting's next week. I know some of you have already volunteered. If you are not yet involved and you would like to be, please put a note in the chat or send me an email. There are different ways to be involved with like differing levels of time commitment. We'd love to hear from you. Also, I'll stick this link in the chat after I finish talking, but we do have a very quick survey asking for input on what types of questions you all get asked about birds and offshore wind. So we'd really love your feedback on like what kinds of questions do you get from different people, and that'll help us decide what types of questions to include in the FAQ. Okay, second project update. We have another eTwig specialist committee that has since completed. It was convened in 2022. Again, many of you were involved in this. The goal was to inform pre and post construction monitoring and research conducted at the scale of individual offshore wind projects. And in particular to inform sort of primarily developer funded monitoring at the individual project scale that's aimed at detecting and characterizing displacement and attraction and sort of meso to macro scale avoidance of marine birds at offshore wind facilities in US waters. BOEM does have existing guidance for developers for conducting avian site characterization surveys. So these are either boat-based or aerial surveys to inform the permitting process, so like before offshore wind farms are built. But the BOEM guidelines don't really get into how to conduct surveys or other types of studies besides surveys, but to conduct surveys to actually detect effects to birds from offshore wind farms that are built, right? So like sort of before, after comparisons to look at change. So this committee was formed to help provide some specifics for how to best examine effects of offshore wind facilities like displacement on marine bird species. And then also help to sort of standardize this type of effect research across wind farms so that we can better understand how site level effects might sort of translate up into impacts to population or ecosystems. I've talked about this effort at previous AMBC meetings, so I'm not going to go into a ton of detail here, but I wanted to at least briefly mention that this guidance document is now finalized and publicly available. As part of that effort, we conducted a literature review of existing empirical studies of displacement and avoidance in Europe. And the goal here was to understand potential sources of variation in responses observed at different wind farms and dig into aspects of study design that could influence the statistical power of each of those studies. And so the committee used the results of this review to help inform some of the recommendations in the guidance document. And Juliet Lamb at TNC also led a meta-analysis of that data set, which was published earlier this year. And again, it was looking at those factors that influence the likelihood of detecting displacement or attraction in the studies that have been conducted to date in relation to factors like wind farm study design characteristics, in species, time of year, different observation processes, that kind of thing. So the final guidance document developed by the eTwig committee is now publicly available on the committee webpage. It's at this QR code. The guidance identifies key research questions, a process for selecting focal taxa for study, data collection methods, focus again on sort of that individual offshore wind lease area scale. We talk about how to design studies that provide adequate statistical power to detect effects. We talk through strengths and limitations of different study methods. And then we make some very specific detailed recommendations for the use of observational surveys, so boat-based and aerial surveys. And that includes methodological details, like some of the stuff Chris was talking about for the Gulf of Mexico surveys earlier, as well as study design recommendations, like the use of sort of gradient designs rather than control impact designs, as well as some data analysis and transparency recommendations. So this guidance was released this past summer. And again, the intent is really to help standardize and improve the quality of site-specific monitoring efforts. And a working group of the Regional Wildlife Science Collaborative for Offshore Wind, or RWSE, is now picking up where this eTwig committee left off. The RWSE working group is being led by Patrick Roberts at Fish and Wildlife Service. He talked about this during the Marine Spatial Planning meeting yesterday. So if you're interested in continuing to be involved in some of these ongoing discussions about where we go from here, definitely reach out to Patrick. Okay, last project I wanted to give a quick update on is Project WOW, Wildlife and Offshore Wind, which is a 5-year study to assess the effects of the first commercial scale offshore wind energy developments on marine mammals, sea turtles, birds, and bats. And as part of Project WOW, we're deploying 120 GPS GSM tags in 2023 to 2025 on great blackback gulls and northern gannets. And the deployment locations are in Massachusetts and New York. Project WOW is quite a large consortium. It's led by Duke University. We have a range of sort of areas of research focus, but two of the key questions we're trying to answer is how avian habitat use is changing in relation to offshore wind development. So again, trying to get at sort of displacement and avoidance questions. And then what patterns of avian flight behavior may contribute to collision risk in the offshore environment, and what are the environmental drivers of those patterns? So trying to understand more about things like flight height and flight speed. Individual tracking isn't the only approach we're taking to try and get at these questions, but it's quite an important component. So the Great Blackback Gull tagging is complete. That was led by Stony Brook University. They put out 16 tags in Massachusetts in 2023 and another 41 in New York and Massachusetts in 2024 during the breeding season. Each bird's a different color on this map. I know it's total spaghetti map, but as you would expect, during the breeding season, bird movements were really concentrated around the breeding colonies. Once you start getting later into the sort of non-breeding season, you start seeing some much broader scale movement patterns, as well as some, I think, really interesting interannual variation in these patterns. Wind farms around this area are now sort of in different phases, right? So like South Fork Wind Farm is now fully operational. Vineyard Wind 1 is still in construction. Empire Wind in New York is still in pre-construction. So it's going to be interesting to try and analyze these movement data in relation to offshore wind development that is in sort of all different stages in different places. And also those stages are sort of changing over time. So Esther at Stony Brook is leading analysis of this data set as part of her dissertation. So definitely stay tuned for more information on this in the coming years. And we're also tagging northern gannets during the non-breeding season, so catching them at sea during the winter. In 2023, we tagged 15 birds off of Long Island and Cape Cod. The Long Island birds captured in November really just sort of kept on moving south. The Cape Cod birds captured in December tended to sort of stick around our sort of primary region of interest a little bit more. We're doing tail-mounted tags, and the gannets were actually still actively molting their tails in November and December, which we did not know they were going to be doing. Did not realize that beforehand. So we're pushing capture efforts back to January this winter to hopefully catch birds once they're done molting their tails, or at least farther along. And are planning captures on Long Island, Block Island, and Nantucket. So hopefully we will get some more tags out in January. We also have formed an international flight height working group. Evan mentioned this in the chat a bit earlier, focused on trying to understand bias and altitude estimates derived from GPS transmitters. This is relevant for these Project WOW tags, for the SCRAM collision risk model that Holly's talking about later. There's a bunch of research going on around flight heights in relation to offshore wind development in Europe. So we're trying to make sure we're sharing information and ideas about how to handle both uncertainty and potential bias in altitude estimates from GPS transmitters during the analysis process. So that was some sort of quick updates on a couple of recent and ongoing activities. Happy to provide additional information. Anyone who's interested, please reach out. And if you see any big aggregations of gannets in the next month or two, just shoot me an email and let me know where. It would be much appreciated. Thanks.
I think we're out of time for questions for this one, but please put them in the chat / keep them for after the next couple talks.
Hi there, Allison. I think I'm up next.
Yes, Stephanie
Okay.
Avery-Gomm is up next, and feel free to take
Excellent.
it away.
Okay, thank you. Thanks very much. So keeping with this theme of offshore wind, I'm going to be presenting a framework for assessing the cumulative effects of offshore wind energy development and other pressures on wildlife. So my name is Stephanie Avery-Gomm. I'm a research scientist with Environment and Climate Change Canada in the Science and Technology branch. And today I'm presenting on behalf of my my collaborators at BRI, the Biodiversity Research Institute, including Kate, as well as Megan, Wing, and Evan, and colleagues as well from the Canadian Wildlife Service, Paul Kanaga specifically. So I don't need to tell this audience that the pace of offshore wind energy development is accelerating. What you might not know is that in Eastern Canada, we have exceptional wind resources, and so this presents an opportunity for clean energy opportunities in the Atlantic provinces. Those opportunities also come with challenges, of course. Offshore wind poses risks to wildlife species, especially those that Environment and Climate Change Canada has a mandate to conserve and manage. So that includes marine birds that forage at sea, migratory birds and bats, and in Nova Scotia, potentially also the monarch butterfly, which is a species at risk. Offshore wind farms can lead to direct impacts, such as collision, habitat displacement, and disruption of migratory routes, as well as indirect effects like habitat modifications and behavioral disturbance. So understanding how all of these effects interact and accumulate over space and time is really complex. I really like this figure from Kate that illustrates how individual impacts such as collision, behavioral change, and habitat-mediated change can sort of accumulate to result in population-level responses and cumulative impacts. But what isn't shown here are the other pressures like pollution, fisheries, harvest, disease, and climate change, which also affect wildlife. So understanding the cumulative effects of offshore wind energy developments and those other pressures on population size and structure is a really significant challenge. And cumulative effects assessments are a systematic approach for evaluating these combined impacts. And these cumulative effects assessments, particularly when conducted at a regional scale, are really critical during the early planning phases of offshore wind energy development. This is especially true because many of the mitigation measures for offshore wind energy development remain unproven, as Julia just explained. And so right now, one of the most effective strategies is to site wind farms away from high-risk areas. So to clarify how cumulative effects assessments can fit into the process, I just want to briefly outline the 3 phases of offshore wind energy development planning. So first you've got and can you see my cursor here? I'm going to assume you can. Someone chime in if you can.
Yes, we can.
Okay, great. So we've got our first phase, regional assessment and offshore wind energy development area delineation. It's a mouthful. So this is an initial spatial planning phase that identifies broad areas within the broad areas for potential development. And so that's shown here in this top figure by a gray box within a larger white box. In Canada, regional assessments are currently underway in Nova Scotia and in Newfoundland and Labrador that aim at refining these future development areas. And so in the figure here, you can see the dark polygons indicate these areas that the regional assessment committees have identified as offshore wind development areas or potential future offshore wind development areas within the larger region. So regional cumulative effects assessments can provide a critical insight at this stage by identifying areas where cumulative effects from developments and other activities could be minimized. The next phase is site selection, and so that's sort of indicated with this number 2, and that's where we go from having this larger gray polygon to a number of licensing areas within that gray polygon. And so in Nova Scotia, we are expecting, or Nova Scotia is expecting to be having a call for bids in early 2025 in January, and to be licensing submerged land licenses as early as 2026. Regional cumulative effects assessments remain critical here because they can help to highlight areas within that gray space or within these darker polygons where licenses could pose lower risk of cumulative effects on wildlife. The final stage is site evaluation. So that's shown here as like a red box. And these are site-specific or project-specific impact assessments, and cumulative effects assessments are part of that. And while those assessments are focused on localized impacts, regional cumulative effects assessments conducted earlier can still inform that phase, particularly by providing a broader understanding of cumulative effects and helping to contextualize those project level cumulative effects assessment, thereby sort of addressing one of the most common shortcomings of project level cumulative effects assessments. So I mentioned there's 2 regional assessments underway in Canada. These started in March 2023 and will both be wrapping up in January 2025. And regional assessments purportedly offer an opportunity for assessing and managing cumulative effects at a regional scale, which of course very important. But despite their importance, these cumulative effects assessments were not actually included in the draft final reports for Nova Scotia or Newfoundland and Labrador. The committees cited resource and guidance limitations as reasons for that. For instance, the Nova Scotia Committee stated the committee has had neither the time nor resources to develop a sophisticated approach to the challenges posed by the terms of reference with respect to cumulative effects. And so that's a little bit unfortunate. That's the unfortunate news. The good news, maybe, is that Environment and Climate Change Canada, together with BRI, have been actively working to sort of address those gaps. So our goal is to develop and demonstrate a flexible approach for assessing cumulative effects of offshore wind and other pressures on wildlife in Atlantic Canada. Over the past year, we've worked, and particularly shout out to Megan Ferguson, who's done a lot of the heavy lifting here, worked to synthesize knowledge from cumulative effects practices in the US and in the European Union, where offshore wind energy industries are more developed. And we've also reviewed recent Canadian cumulative effects assessments that have occurred at a regional scale, even if they're not specific to offshore wind. And we started with this because we knew that understanding the strengths and weaknesses of regional cumulative effects approaches in other jurisdictions would allow us to create a more robust framework and analytical strategy for undertaking a regional cumulative effects assessment in Atlantic Canada. The next step there then is to demonstrate that approach with a couple of case studies, and that work is underway and will continue through 2027. And although it's too late then for the results of the case study to directly inform or influence the regional assessments, we are engaged with I am engaged with the province of Nova Scotia and industry and federal working groups to ensure that the scenarios that we develop are relevant and to find ways for our work to guide the decisions on submerged land licenses as those sort of processes move forward. So now I just want to introduce this framework. This is available up on bioRxiv as a preprint. It is, I'm really proud of this work. So this is where we have distilled the complex process of conducting a cumulative effects assessment into a coherent, detailed, and comprehensive framework. The first 4 sections of the document serve as a practical guidance resource, laying out the fundamental steps of a regional cumulative effects assessment in a clear and accessible way. And those steps address all of the critical considerations, including setting baselines, scenario development, and the integration of expert knowledge. and uncertainty. The framework is designed to be practical and user-friendly. And our framework does employ a species-based approach. And although aerofauna are the focus of the current application and the case studies it will do, the framework is broadly applicable to any wildlife species without requiring modification, as a reviewer pointed out, which is why we have changed the title. One of the greatest strengths is the adaptability of the analytical framework. So just to walk you through that briefly, the framework accommodates a wide variety of spatial data on species, from simple presence-absence data down to absolute density data. This information is then combined with data on pressures, such as if you've got information on the distribution, magnitude, or even if you've got information on the effect of pressures, any can be used. And together, these are used to inform a cumulative effects metric, and that metric synthesizes what we know about each species pressure combination. Higher quality information is indicated with darker shading, and once the cumulative effects metric is selected, the spatial optimization is run iteratively for each of the scenarios that were defined during an earlier stage of the scoping, which I haven't talked about. It's described in the paper. And then the output of each scenario, or the output for each scenario rather, is the optimal spatial configuration of offshore wind energy development that will minimize the cumulative effects metric, or an average of valid solutions. If the combination of species and pressures included in the cumulative effects scope requires the use of multiple metrics, the framework allows for additional steps that aren't shown here, just to sort of keep this simple and keep the talk on time. So importantly, the framework standardizes cumulative effects metrics, creating a consistent and comparable method to highlight areas where licenses of offshore wind energy development will minimize cumulative effects on receptor species. Our motivation for publishing this framework as a standalone was to sort of validate it through peer review before applying it to a case study. And that manuscript is currently under in the second round of reviews, but we have received enough encouraging feedback about it from reviewers, as well as 5 external subject matter experts, for us to sort of feel like we've got a valid thing going here. So we've started work on the case studies. Our demonstration case study focuses on Northern Gannets and explores offshore wind energy development scenarios within the areas that have been identified in the latest or the final regional assessment reports. And the key aspects include that we are focusing specifically and only on the operational stage, and looking at a 40-year time frame. And then, as I mentioned, we're developing scenarios in consultation with provincial and industry stakeholders. This case study will not only demonstrate the framework and the flexibility of the framework, but will also provide actionable insight for minimizing cumulative effects in offshore wind energy development. So in conclusion, regional cumulative effects assessment research is really important, especially at this early stage of the offshore wind industry development in Canada. And we hope that through frameworks like this one, we're going to be able to support some informed science-based decision-making that balances Canada's clean energy transition with protection of migratory birds and their habitats. This work has been supported by a lot of people, including a lot of the people on this call. So thank you very much. And if you would like to follow along with this project, send me an email and I can add you to our occasional update list. Thank you.
Thanks, Stephanie. I think we are probably still running a little late. Allison, do we have time for any questions, or should we push them to the chat and discussion?
Yeah, we have 3 minutes for questions if people
Okay,
would like
great.
to use them now.
Any questions for Stephanie? Stephanie, oh, go ahead, Caleb.
Yeah, good talk. It is a really interesting way of doing this, and proactive. I like the getting ahead of it in Canada. My question is about I'm thinking about the way that suitability has been assessed in the U.S. BOEM is using NOAA-based suitability models that incorporate a lot of different inputs, not just birds. And I'm wondering how adaptive the model would be to incorporate other sort of factors. or at least identify those areas where birds should not be in some way that could be incorporated into a model that includes other factors.
I'm sure I understand your question. Are you asking whether or not other species, like non-bird species, could be incorporated? Or
Yeah.
are you asking about how the like regional assessment process has delineated the current areas?
I'm thinking about non-birds and not just
Yeah.
non-birds, but there's again, the way that there's a lot of different considerations that would include other marine spatial planning uses, defense, things like that. And again, I guess I just am not sure what the output is. If the output is sort of like a I don't know, some kind of scale of suitability for birds, that could be incorporated.
Yeah, I understand. So the output
Yeah.
is going to be like a layer that a spatial layer that gives you a cumulative effects metric in each of the hex cells that we use, and we're going to use the same ones as DFO uses. And there is, at least in Nova Scotia, DFO has done a fairly good mark-sand analysis to inform planning, and that was used quite heavily in the regional assessment committee in Nova Scotia to identify those polygons, or at least it was one of the several documents they used. Unfortunately, that product didn't include a ton of bird data, and so it was a little light on the bird data. And so I kind of see the output of this cumulative effects, of the case study, and ideally doing it for multiple species, not just Northern Gannet, because we care about more than Northern Gannets, but being sort of an input to that sort of spatial planning process, just so that they're better represented.
That's great.
Great. Thanks, Stephanie. Holly, are you online? Do you want to start sharing your screen?
Sure. How is the sound? Can you hear me? Okay.
Yep.
All right. Yeah. There. Right.
We are seeing your desktop, I think.
Yeah. There we go. Can you see that?
Yep, looks great.
Great. Okay, well, thank you all. For those of you who don't know me, I'm Holly Goyert, Senior Quantitative Ecologist at Biodiversity Research Institute. And today we'll be talking about SCRAM, the Stochastic Collision Risk Assessment for Movement. So this was a collaborative effort between BRI and the Fish and Wildlife Service, Pamela Loring, that's shown here as co-author, and it was funded by BOEM. SCRAM 3 is currently under development with funding from the Fish and Wildlife Service. And we have a couple new team members, Kim Lato and Michael Wethington, who joined us recently at BRI from Stony Brook. So a collision risk model estimates the number of expected collisions between an object and a population of animals over a designated time frame. And collision risk models are currently used globally in the offshore realm. Were first derived in 2012 by Bill Band. So over the last decade, they've developed a few new specifications. For example, they're now stochastic to account for statistical noise and variability, and they're specified in R rather than Excel. They are also publicly accessible on an online R-Shiny app and via an R package named Stoke CRM. SCRAM has incorporated all of these features. So SCRAM is stochastic, available publicly via an R-Shiny platform, and it runs using the Stoke CRM functionality. The R-Shiny platform now even allows the user to select between running SCRAM or running a stochastic version of the Band 2012 migratory model, which we refer to as Annex 6, and I'll speak more to that later. The primary difference between SCRAM and its predecessors implemented in Europe is that rather than using survey data, SCRAM uses movement data to inform migratory use of the offshore environment and estimate collision risk. So the reason for this is because offshore surveys in the US are not designed to target these 3 federally listed species. This limits the sampling of red knots and piping plovers, which are the 2 shorebird species shown here on the left, as well as roseate terns, which we can, for the purposes of this talk, call a seabird or coastal waterbird. But we do have movement data on these species from both MODIS and satellite-based tags in some cases. A caveat is that tracking studies can be biased based on the location of tag deployments or on constraints in the tagging technology. So, for example, historically, these species were only tagged with MODIS transmitters, which you can see shown on the plover in the middle. And these were detected by MODIS automated radio telemetry receiving stations located on shore. And because of tag loss after a few months, roseate terns tagged during the breeding season are often only tracked through post-breeding and not migration. Similarly, tag deployments that occurred mid-migration, for example, in Delaware Bay, for red knots don't fully capture offshore migratory routes, especially when tag loss occurs. So fortunately, relatively new satellite-based tags have helped inform fall migratory routes of red knots, and then even newer technologies being used to track these species from South America to inform spring migration, and possibly even the full migratory cycle. So I think we're going to hear a little bit about that tomorrow morning. And because of some of these spatial and temporal biases, an update to the online platform for SCRAM allows users to run collision risk models based on movement data, as well as the band 2012 Annex 6 migrant model, which again has been used for migratory species in Europe. The service uses both these models, SCRAM and band, in their consultations with the offshore wind energy industry to estimate projected take of these listed species. And that's, of course, from collisions with turbines offshore. But I will note that the update to SCRAM is under review by BOEM. It will be released soon. But if you were to go right now to the website, that is SCRAM 1. What I'm speaking today is on SCRAM 2 that is currently under review and hopefully available shortly for public access. So how does band compare to SCRAM? Here you can see the components of collision risk models with data inputs in blue, estimating models in green, and the online platform or user interface in orange. And for both band and SCRAM, we use regional population size data as an input for each species, and that's provided by the Fish and Wildlife Service. The models also both use MODIS and GPS data to estimate the distribution of flight heights within the vertical swept zone. For example, to estimate exposure in the vertical plane, and to estimate distributions or exposure across the horizontal plane. The band Annex 6 model uses migratory corridor width estimated by Fish and Wildlife Service species experts. So given how many animals pass through the study area in a given month and how wide the migratory corridor is, band Annex 6 estimates the monthly passage rate at a given latitude. And then these passage rates, along with species and turbine data, are then used to inform the collision risk model that is accessible via the open source application. But the key assumption of band Annex 6 is that migrants are uniformly distributed throughout the migratory corridor. And this assumption may hold more true for some species than others. For example, some songbirds may migrate across a broad front, whereas shorebirds or waterfowl migrate in flock through key stopover areas. In contrast to this, SCRAM movement models allow for variability in the distribution of birds across the study area. So instead of using migratory corridor width, SCRAM uses movement models derived from MODIS, GPS, and Argos data. And these models estimate variation in habitat use from the movement modeling. So the exposure estimates from both band and SCRAM are then converted to passage rates and used to inform the collision risk model accessible via the open source web platform. But what are the parameters that inform the collision risk model? As shown here, you can see that these include morphometric information like species size and behavioral data, like flight speed or avoidance rate. And then, of course, we also need the planned size and number of wind turbines, the average speed of the turbine blades, and more. So you can think of this as if you're throwing balls at a fan. A beach ball would be more likely to hit the fan blades than a tennis ball, purely based on size. And if the fan is rotating faster on high, then basically either ball is more likely to hit. So the number of balls in the vicinity of the fan represent the passage rates. And in SCRAM, we use the movement and flight height distribution models to estimate exposure. So this is, again, what we're calling now passage rates. Then we need the wind turbine data to estimate or to determine the proportion of time out of the year that birds are exposed to rotating blades during turbine operations. And then we also need the physical properties of turbines, like their size, to determine whether estimated flight heights fall within the rotor swept zone. We also need to know how they operate. So for example, RPMs may vary with wind speed, and we can take that standard deviation into account in the collision risk models. We input morphometric species data like size and behavioral data to calculate collision probability. And the online platform allows users to input turbine parameters and estimate risk in a consistent and transparent manner. The final estimates of collision probability include uncertainty generated from each component, and that includes both uncertainty from the movement models, also the flight height models, the species inputs, and the turbine inputs that gets propagated through until and integrated into the final estimates. So here we have a comparison of flight height estimates for red knots between SCRAM versions. SCRAM 2, shown here on the top, uses a state space modeling framework to estimate flight heights from GPS transmitters deployed from 2020 to 2023. Whereas SCRAM 1, on the bottom, used estimates from a movement model based on data for MODIS tags to estimate the position of the animal. And then this shows the smoothed tracks of red knots based on 4 years of newly available satellite telemetry data from 6 different sources. These models used a continuous time correlated random walk and were limited to fall migration to avoid bias. And you can see on the right is the mean cumulative exposure of red knots based on the movement models. So that's kind of like a proportion occurrence in each grid cell throughout an entire month, or the number of days in a month where individuals were observed or detected. We combine those GPS outputs with outputs from the MODIS movement models in an ensemble approach, or specifically the geographic areas that overlap between the two models. And those were all the way from Virginia to Massachusetts, which I'll show you in a following slide. Now for piping plovers, here we have the predicted movements of a plover that traveled from Rhode Island to Virginia and back up the coast over the course of 3 weeks. And shout out to our new staff member, Michael Wethington, who created this video. This particular bird was a rare bird, so it was the only one of 115 that traveled north along the coast after migrating south. However, I chose this particular bird just for the purpose of illustrating how the model handles behaviors and how it handles uncertainty. So if you notice, the bird traveled fast across the New York Bight and then moved slower between stopover sites along the coast. And that shows that this bird is displaying 2 distinct behaviors: fast migratory movements and then slow staging movements. So the movement model we use for the MODIS data can accommodate both of these movement types. It's called a hierarchical, discrete time, continuous space, correlated random walk model. But because most of the birds in this case show one or the other behavior, the 2-state model was failing. So SCRAM 2 now uses a single state movement model. And now that we're integrating more sources of data, we're continuing to develop the model to determine if the 2-state model better captures behavioral variability. So this is the same individual just shown as a static map rather than a video. And you can see here how that same bird was detected at 5 stations, which are the white dots shown on shore on the left. I don't know if you can see those there. But the dark dots show the predictive movement track based on these detections, 1 for each day. And the light blue point cloud around the dots represents uncertainty in the estimate. So notice that the faster the bird is moving, the smaller the point cloud around the dots. So the less uncertainty and the more confidence we can have in that location. So if a bird is moving at its maximum flight speed from one point to another, we can be fairly certain about drawing a straight line between those 2 points. But when there's more time between points, it could have traveled slowly in a straight line or fast in a sinuous line. So when there are greater time gaps between detections, there are more locations where that bird could have flown depending on its speed. And that's the case for any telemetry data, whether from satellite tracking or MODIS. But the problem inherent to MODIS data is that stations are relatively far apart and located only on land. So there are greater gaps between MODIS detections than GPS data, and the models have trouble resolving this. Nevertheless, we use a Bayesian framework for the MODIS data, which propagates this uncertainty all the way through to the collision risk estimates. And that, along with the uncertainty in flight heights, collision risk parameters, all leads to a mean and a standard deviation around each collision risk estimate reported in the app. So one other way that we handled time gaps in MODIS data in SCRAM 2 was by reducing the study area to active MODIS receivers This is why you see the study area extending only from Virginia to Massachusetts for plovers and roseates on the either end of this, on the left and right side. And because these use only MODIS data and SCRAM2. And as mentioned earlier, we're planning to incorporate new GPS data for roseate terns as they become available. We were already able to integrate modeled GPS data with modeled MODIS data for red knots using an ensemble approach, which you can see by that red line with the overlapping areas. And like I said earlier, SCRAM2 is currently under review by BOEM, set to be released soon. It's resulted in decreased collision risk estimates in some study area grid cells and increases in others. But generally speaking, changes in the movement models smoothed out effects to reduce the highest highs and increase the lowest lows. So this is due to many improvements that we made to SCRAM2, shown here. Not only did we update the movement models, but we also provided updated population numbers from the service, and we increased the speed, the computing time of the online platform. We recently entered phase 3 of SCRAM and brought in a couple new team members, like I mentioned earlier, to work on the project. We now have support from the Fish and Wildlife Service, but continuing our engagement with BOEM. We're continuing to host and update the web application, including proportional adjustment to account for wind farms across multiple model cells. We are continuing to update the structure of the movement models with improved precision and use new data. We're developing the flight height modeling process. We are planning to conduct sensitivity testing to specify assumptions and identify key parameters. We are working with international collaborators to develop a common approach for cumulative effects estimates, as well as a flight height working group. And we've had the U.S. Geological Survey review SCRAM1. We're having them review SCRAM2 as well, including collision risk model experts in the UK. We also are incorporating outreach activities to better inform on SCRAM and collision risk models in general. So we'd like to thank all of the data providers and reviewers of SCRAM, and I'll leave it at that and ask if you have any questions.
Great, thanks, Holly. Any questions for Holly on the SCRAM collision risk model? Holly, I will ask one, I guess. We do have some survey data for roseate terns, right? We don't only have tracking data for roseates. So are the survey data for roseates being used in SCRAM to help understand exposure right now?
No. So those would be used in more of what we call as a flux model. And we are incorporating data from other species like Northern Gannets at present that do have survey data. So that's basically in progress, part of phase 3. The part of the problem with the survey data for roseate terns, though, is that there's just underrepresentation in surveys. So we've been thinking about how to address this and whether we, once we develop the flux model, if we can sort of adapt it to roseate terns as well, but then we'd have to do a lot more thinking in terms of weighting the different model inputs to make sure that they are appropriately represented in the analysis.
Thanks. Peter?
Peter, yeah.
Hi, great talk. So how is avoidance of the turbines incorporated into SCRAM?
Avoidance of the turbines? Yeah, that's one of the parameters. I showed it. It's macro avoidance rates that are included, micro avoidance rates that are included based on studies in Europe. Those are parameters that we've included from the literature. And it is sensitive to those parameters for sure, which is partly why we're planning to incorporate a sensitivity analysis into this, and also continue to update those rates as they become available with new studies. And other folks also are welcome to jump in. So like, I don't know if Andrew's on the call now or Evan, I'm just looking at the names here, but feel free to jump in if other folks on the team have comments on that.
Yeah, I mean, we're just using a sort of the best available micro to meso avoidance rate from Europe for gulls and terns for all 3 species, because we don't have a species specific or even like taxonomic specific reliable avoidance rate we feel good about for shorebirds at the moment. It's a big data gap.
Thank you.
Joan?
Yeah, thanks, Holly. That was great. I just wanted to reiterate what I said yesterday. We do have the beginnings of a project for getting information for birds transiting, for roseate terns transiting northward. And we also have good partners now in Brazil, so we'll be able to put receivers out in Brazil to get birds transiting southward, as well as going down in the winter and getting birds transiting northward. But we don't have funding for that. So it's important for us to continue to put that on the front burner if we're gonna be able to get the data that you need for SCRAM 3, which looked like it's 2025 or 2026. We've only got a few seasons to get those sample sizes up. I just wanted to mention that one more time. If we don't get transmitters on birds and that costs money, we're not going to have the data that we need.
Right. Yeah, I hear you, Joan. And that's something that we're constantly have our eyes and ears out for, is more data. It's really exciting to get the spring migration data for roseate terns. That's something we don't have at all. As I mentioned, right now, it's just covering post-breeding season, basically, and that's it, not even fall migration. I think those data will be great. We will have to handle, small sample size questions with that, but anything we can get. And that's also why we're starting to think of using common terns as a surrogate as well. But again, that's, I think, a question for other potential funders. Maybe we can be creative going forward to find other ways to bring in more data.
I don't think we really need to use commons as a surrogate. I think that we know how to do it now with roseates. So I think that we've cracked it.
Great.
Thanks.
And Holly, there's a question for you in the chat about whether the model it accounts for whether blades are turning or not, and also whether it accounts for, I think that species movements in relation to environmental conditions like wind, I think is what we're getting at.
Yeah, so I did mention that it does account for the operational time, right? So that's basically when the turbine's spinning versus not. Or I guess maybe that's taking away the time that the turbine's under maintenance, right? The opposite, which would be downtime.
There's two separate
go ahead,
things, right?
Evan.
There's like the maintenance time, and then there's the operational time. And then we account for the rotational speed of the turbine blades and the wind speed themselves. So it's actually it's like we account for both things, like when they're down for maintenance and when they're not spinning.
That's right. So yeah, and that was one update that I didn't mention explicitly, but that was changed in terms of whether we're using RPMs versus actual wind speed, but you can convert between the two. Just note that we are using these values at a monthly scale. So it's not at a daily scale yet. We've talked about trying to get it to a higher temporal resolution, but for now, for the purposes of the regulatory processes, this is the temporal scale at which we have been working.
Well, going back to Joan's point, we just don't have the sample size to sort of split stuff up any more finely than that.
Yeah.
I like the yet threat there. I
I
don't
know,
want to
right? It
be
sounded
I
like
don't
it
want to
was
be in
limited.
charge of figuring out daily maintenance probabilities for these turbines. So let's maybe some of that stuff can live at the monthly scale.
Yeah.
Julia?
Yeah, no, I was just wondering with the tracking data and stuff, whether you have like the wind resource, the supporting wind resource information. So what wind speeds and directions birds are moving, and account for that into whether it's likely that they're going to encounter when blades are spinning or not spinning, just based on what we've been seeing, at the turbines when we get most of the numbers when blades aren't turning. So I just wondered if you can accommodate some of that information.
So are you talking about like tailwinds versus upwind movement? Is that what you're referring to, versus when the turbines are spinning?
When we've been reviewing some of our data, then obviously the wind resource at the time that species are encountered, there's, except for, I think Greg mentioned it, except for like gulls, there's quite distinct cutoff time, cutoff wind speeds when when those movements seem to not happen. And so, you know, so I was just wondering whether it could be sort of thought about, like, how often do those wind regimes happen? So when are those, so the cutting speed, if it's around 5 meters per second, for example, could potentially take out quite a few of those movements. But I don't know without, you know, you all know that better than me, looking at the tracking data and the wind resources where those tracks have been recorded.
Yeah, it's a good question. I'll leave it to Evan if he wants to answer that. But I will say there is a parameter there that is a proportion of upwind flight. And how that's derived is...
Well, it isn't right now. It's just assumed to be 50-50, I think, in the default band model.
It's more of an assumption. Right now, essentially, we assume that and this is a big one, obviously, that all bird tracks are, you know, perpendicular to the turbine blades. So that's just something that's been like a long-standing assumption in the band models. To Julia's point about like wind speed and sort of like peak turbine RPMs maybe not matching to peak bird activity. There's not a way to handle that in the band models currently, but it's something we could consider adding. I could see ways that it could work. Obviously, we need some data to support it, but if there are some data out there that we could look at, that's something I would be interested in doing. And
Pam in the chat said we would probably need a lot more information on species site and temporal variability with respect to wind use. Yeah. Although with you know, these smaller GPS tags and getting them out on more birds and more species, like we might start getting to the point in the next few years where we have the data to do that for at least some species, but we certainly haven't historically.
Yeah, right now with the tags, the sampling rate's pretty low on them, and so like looking at like wind assist is like pretty, you know, I would say like if not clunky, certainly pretty big picture. And so we haven't looked into it too much, but it'd be fun to try.
Caleb?
I'm sure you guys have been thinking about this, but I'm just curious to know about this. These are at the site level. The collision risk is at individual, the level of the individual plan development. Has there been discussion about cumulative impacts from multiple developments and how you would even go about trying to figure that out?
Yeah, that's one of the focuses of this international collision risk modeling group that we've started up.
Okay.
There are some challenges within a jurisdiction in terms of thinking about how to apply a collision risk model across multiple projects. So like if you assume a bird has collided with wind farm A, you have to remove it from the population available to collide with wind farm B. You know, there's some that kind of stuff. But then also between jurisdictions, the models that people are using to assess risk can differ. A lot of the current collision risk models in current use are sort of from the same lineage of band style models, but they can differ a fair bit in some cases. The Australian version of the collision risk model, for example, has some different, you know, they assess collision with like the stationary parts of the turbine and not just the blades. And like there's some different things here. And so you also have to think about, I don't think you can just like sort of add up estimated collision risk as if they were it was just an apples to apples comparison. So this is something we are continuing to talk about. I think it's going to take a while to sort of work through.
Yeah, it sounds complicated for sure.
Yeah, and
I'll note in the UK. Oh, sorry, Holly.
Oh no, you can go ahead, Evan.
I was just saying, in the UK, they even within jurisdictions, they have trouble doing this. I think mostly what's happened in the UK is they would just run a collision risk model for multiple projects and add them all up. And like, it's a pretty simplistic way of looking at it, but at least I would say it's been consistent and pretty easy to sort of compare from one project or one instance to another. So, I mean, there's some starting points, but it'd be nice to be smarter about it.
Yeah, and I was just going to point out that Pam mentioned in the chat, one thing to also consider is how weather conditions change when birds are underway with offshore movement. They may select conditions at takeoff that change en route. So that was in some early discussions with the flight height distribution working groups about, because I know Keenan has really found some interesting data on flight heights of roseate terns. And currently the flight height distribution models do not account for variability throughout space, but we've been talking about maybe, and that's for Evan to add to if you have anything to say, Evan, but talking about ways to maybe, once we get a hold of those data, to try and incorporate more variability in that.
Yeah, I don't have a whole lot more to say other than these are all things that we're actively working on. It'll be exciting to see some of those new flight height data coming in.
Yep, hopefully we'll be able to include a fair bit of additional data over the next year or so, depending on what's available.
Allison just gave us permission to go for 7 more minutes. So all right.
Saw that.
You got 7 more minutes of questions. We don't have to talk about collision risk models. We had other great
I mean,
talks
does anyone
during the
have any
session.
questions for any of the earlier speakers? I guess
If we want to talk
Turn on my camera.
cumulative assessment models, yeah, we could bring Stephanie on, and if Megan's lurking around here, we could have Megan talk a bit about what was going on in cumulative effects land. I think that's a much more interesting way of thinking about cumulative effects than adding up all the SCRAM assessments. But
I guess one
important.
Oh, did we just have someone raise their hand?
Olivia
disappeared again right away.
I'm unconvinced if she wanted to ask Stephanie a question.
Well, okay, so here's a question. Several of us have talked specifically about Northern Gannets. And I think it might be worth talking a little bit about why there is a focus on Northern Gannets or particular other species, and what other species we should be thinking about also looking at. Stephanie, do you want to start since we have the Northern Gannet focus for the cumulative effects?
Yeah, so I can say, we did gather a group of seabird and landbird and shorebird people back in April and have a conversation about a species. And Northern Gannets came out as a species that we expected to have a collision risk. It's a species that was hammered really hard by a highly pathogenic avian influenza in 2022. So we're estimating somewhere between like 11 and 40% of the breeding population was lost. Somewhere in there. It's like a very broad range. We actually have quite a lot of data for them. And so the reason we chose them is because we'll be able to demonstrate the flexibility of our framework by using all the data on one side and then simplifying that and basically showing what the output would be if you use everything versus if you pretend you don't have everything and you have a more simplistic version of a cumulative effects assessment. Well, that's why we chose Northern Gannets. But I think I would have to pull up the spreadsheet. There's a lot of other species that we heard people talk about. What are some of the other species you guys are thinking about that may be impacted like other effects other than just offshore wind that may deserve attention?
Well, one that's come up recently just for data is wimbrels. So not really for impact question, but just for pretty good data, I suppose.
Julia, do you maybe want to talk about how we settled on the species that we're focused on for WOW tracking?
Yeah, I mean, I think part of it was pulling from what we know about effects from Europe, and gannets are an interesting species because in some contexts they exhibit displacement, and in others, some individuals will actually use the wind farm a lot, and given their flight height, have the potential for high collision risk. So they're potentially a species that may be highly impacted. They're also big, which means if we're trying to put GPS tags on them, it's easier to do that than on a smaller species. And I think it's an interesting comparison to Europe, where a lot of the populations of gannets are breeding, whereas we're talking about non-breeding populations in the US context. So understanding how those potential effects do or don't transfer to the US context is also interesting.
Yeah. And for great blackback gulls, I mean, part of the choice of species there was practical because Leslie Thorne's lab at Stony Brook was already doing some tagging of great blackback and herring gulls, and we're working in those colonies, but also they're the species, maybe not the top, but like right near the top of pretty much every vulnerability assessment, trying to figure out which species are at highest risk of collisions. The large gulls come right out at the top, and there's definitely been observed collisions in Europe. And so trying to understand more about great blackback gull movements offshore and potential collision risk is interesting. There are also lesser blackback gulls. There's also been a bunch of interesting studies in Europe showing that they are at high collision risk, but they also are actually attracted to parts of the wind farm. Like they'll land on like substructures and stuff that's not near the turbine blades. So there's a sort of macro attraction to the wind farm, but then micro avoidance of the areas right around the turbine blades as they're sort of selecting microhabitats and roost spots and stuff. So they're very interesting. And yes, Juliet actually just put in the chat, we should stop talking about both great blackback gulls and gannets probably right now, because we've got more talks coming on both of them this afternoon. Caleb?
Yeah, I was just thinking about that you were asking about what other species, and species that we have data deficiencies, but we know to be using the offshore environment a lot, like particularly in the Gulf of Maine, like we just heard about leech's storm petrel, that's potentially a concern in my mind that we need more information on. Even puffin, I think, may potentially in the Gulf of Maine. And then I say this all the time, but just more information on black-cap petrel. I still think that is a concern, and I know it's really hard because there's just not very many of them, but it's just a species where if we had a potential collision, it would be a big deal. And I don't know, I there's way more people on the line that know more than I do about this, but I just think that it's been something that we I think don't have enough information to make a good kind of informed conservation decision on at the moment.
Yeah, unfortunately, I think that's true for a lot of bird species. And honestly, the data we have for birds is so much better than for most other taxa. And we still don't have the data for most bird species to really be able to assess risk very well, which is why we're defaulting to some species like gannets, where Ian just put in the chat, we've got good breeding population trend data for gannets. They breed in colonies, they're big, they're easy to study. And we still have gaps, let alone for some of the sort of smaller, more cryptic, non-colonial species.
Yeah.
Okay, well, it's 3:57, so I think we probably need to wrap up, but thank you very much to all the speakers for this session. This was great. And I think I'm going to pass over to Juliet now to start the next session.
Yep. Hi, everyone. So this is the tracking session of not common and roseate terns. So all the common and roseate tern tracking stuff is tomorrow morning. Sorry to disappoint everybody. But we have 2 talks in this session, down from 3. I think Kate Goodenough is sick, but may be able to give her talk tomorrow on royal terns. But we're going to start off with Peter Payton, who's going to be presenting on breeding and post-breeding movements of great blackback gulls in southern New England.
Sorry. Is that working now?
Looks good.
All good. Well, thank you very much. Well, I wanted to talk about some preliminary work that Juliet Lamb and I have been doing and looking at movements of blackback gulls. This was supported by a grant from New York Sea Grant. Even though great blackback gulls are one of the most abundant species in our area, there's surprisingly little known about their movements. So this is an opportunity to really start, now that technology has gotten to the point, we can really get an indication of how they move across a landscape. Let's see. Oh, sorry. Okay. So great blackback gulls are found throughout the North Atlantic and Greenland and Iceland and over into Europe. So a relatively broad distribution. And one of the things that you might not be aware of, there's a great overview paper looking at the current population trends for great blackback gulls. And you can see that globally they've declined about 43 to 48%. So numbers of great black-backed gulls peaked in the 1970s and 1990s. In North America, we've experienced almost a 70% decline in the numbers of great black-backed gulls. And in Europe, the decline hasn't been quite as steep. It's about 28%. So there's about 40,000 pairs of great black gulls in North America right now. And one of the interesting things is if you look at the distribution of great black-backed gulls, you can see northern states, the numbers have declined. So in Massachusetts, up to 90% decline, whereas the numbers south in the southern part of the mid-Atlantic, so New Jersey to North Carolina, the numbers have increased dramatically. So there's been this just change in distribution of great black-backed gulls along the east coast of North America in the last 3 decades or so. So Liam Taylor, who asked Joan a question earlier, has a great summary paper bringing up changes in numbers of gulls and terns in the Gulf of Maine. And this clearly shows the pattern. So I've highlighted great black-backed gulls. So you can see their numbers have declined starting in about the 1990s in the Gulf of Maine. And during the same time period, terns numbers have increased, although there's been a little decrease in the number of roseate terns. So I'd encourage you, for people that are interested in thoughts about overpopulation of great black-backed gull populations, to read Liam's paper. It's an interesting overview of the population trends for gulls in the region. And so I'm not going to go into depth of that, but I just want to make you aware of this great paper. So there has been some work on movement ecology done by researchers at Stony Brook, and this just shows movements of great black-backed gulls shown in blue on the left and herring gulls on the right. And you can see that great black-backed gulls tend to be much more pelagic in their movements, whereas herring gulls, at least on Long Island, they were really going to more urban centers. And so typical trip duration for great black-backed gulls are going out on the open water, going out for a little over 2 hours on average, a little bit shorter for herring gulls. And a typical trip distance for great black-backed gull is around 23 kilometers or so. So they're going from the coast of Long Island out to the coast of Connecticut and making their way back. So to initiate this study to look at, we have just a simple box trap made out of large steel mesh so that we could, when we got the birds, they couldn't escape, and just pulled the stick and captured the birds. And then we used PathTrack 25-gram GPS GSM solar powered transmitters. Had a duty cycle of every 20 minutes. We would get a GPS fix. Since they're GSM, they're working on the cell phone network. So we can track the birds throughout their range, and we're constantly getting movement data for the gulls. We don't have to upload to a base station or something like that. So this just gives some idea of the size of the transmitters on the gulls. So it's put on with a backpack harness, and it worked really well. So we tagged 10 birds on South Dumpling Island, which is off of Fisher's Island off the coast of Connecticut, in late May of this year. And then we also tagged another 9 adults at a colony on Block Island National Wildlife Refuge on the northern tip of Block Island. And that picture, so this is off the coast of Connecticut and Rhode Island. And the picture shows the parts of the black-backed colony on Block Island. So this shows the movements. The upper panel is movements of birds during the breeding season. So from late May to mid-July, all the locations of the birds on Block Island. And then lower panel represents movements of birds on South Dumpling Island off of Fisher's Island. Each color represents an individual. So you can see that for the most part, they're staying within about 30 miles of each of the colonies. We had one individual during the breeding season that made a 36-hour trip from Block Island off to Martha's Vineyard and made its way back. And the other thing is you can notice that there seems to be there's little overlap in the movements between these adjacent colonies. So, which is an interesting trend. And if you look at other studies in Europe, they document the same kind of relationship. If you, so their birds are regularly going to the coast of Rhode Island, and then the birds for the Block Island colony, and then for the birds on South Dumpling Island, they're making it way down to Montauk, the tip of Long Island, the coast of Rhode Island, and the coast of Connecticut. And this just shows the same thing so blue represents South Dumpling and red represents Block Island. So this clearly shows a lack of overlap for the most part and movements between these adjacent colonies. And then you can also see for the Block Island colony, the movements of birds out on wind lease areas or active wind farms. So at the northern areas of the wind lease area, that's South Fork Wind Farm, which is an active wind farm in Rhode Island Sound. And then Sunrise Wind Farm, which is on the left-hand side of the wind lease area. That's another wind farm that's being actively constructed right now. So some individuals were regularly making the movements to these wind energy areas. So we hope to really analyze these data in much greater depth when we have some time. So if you look at the typical movements of birds, so the birds on Block Island, this is the farthest distance that an individual went on its foraging trip. So it averaged about 14 kilometers for birds on Block Island, and not as far for those birds on South Dumpling Island, about 8 kilometers. And then if you look at the mean foraging duration, since the birds on Block Island are traveling farther, it takes them longer, so that an individual foraging trip an average is about 4 hours, so it can range up to 7 hours in a given foraging trip. And that tend to be much shorter duration, more consistently for those birds on South Dumpling Island, a little bit less than 3 hours for an individual foraging trip. So since the birds are traveling farther on Block Island, they tend to take less foraging trips per day. So an average of about 1.7 foraging trips per day for the birds on Block Island versus those birds on South Dumpling Island. They tend to do more foraging trips, averaging about 3 foraging trips per day. So this just gives you a sense of the individual variation and movements. So each panel represents a bird, one individual on Block Island. And you can see that they're somewhat consistent in the movements. There's a moving from Block Island. I don't know if you can see my cursor, but they're moving from Block Island here to the coast of Rhode Island consistently off towards the wind lease areas. But some individuals are just going towards the coast of Rhode Island, or this individual in particular is regularly taking trips of the coast of Rhode Island, not going to these areas offshore as much. So as you might expect, there's a fair amount of individual variation amongst movements. These are all during movements during the breeding season. After the breeding season, so these are data from mid-July through early November. The data will still be collected. We hope that these transmitters last for several years. So this is just the very beginning insights into the movements of the birds. So the upper panels represent birds who were tagged on Block Island, and the lower panels represent birds on South Dumpling. So you can see they've moved from the breeding colony at Block Island, at least some individuals, and then some individuals are making it down to New York City, and they're following the coast of Long Island. And then, interestingly, one individual followed the I-95 corridor from New York City down to Philadelphia. That's about another 330 kilometers, whereas other individuals flew along the coast to eventually reach Delaware Bay. So that's about 430 kilometers from Block Island. And those individuals are still residing in Delaware Bay at this time. And so same thing for South Dumpling Island, though we had one individual from South Dumpling Island that's now down in the Chesapeake Bay. So that's about 650 kilometers. And interestingly, that bird too took that inland trajectory, going from New York City to Philadelphia, then down to northern Chesapeake Bay before they made their way down south. And that's where that individual is right now. And as you look at the movements of these individuals in relationship to offshore wind, again, red represents Block Island, blue is South Dumpling Island. You can see that for the most part, they're hugging, the adults were hugging the coast during these movements. One individual actually went to Delaware Bay and then went back offshore, missed the wind lease areas as they made their way back to New York City. So it'd be really interesting to see over time what these movements are like in the long term in relationship to offshore wind. And then we had one individual that moved north to the Cape as well too. And again, this shows individual variation in these post-breeding season movements. So at least for the birds we marked on Block Island and tracked them, only 4 of the individuals had these relatively long distance movements. 4 of the individuals are still residing around Block Island and the coast of Rhode Island, so they haven't dispersed very far. It's all versus some individuals are going fairly far down the coast. And again, for South Dumpling Island, even fewer. We only had 2 individuals. This one individual that explored Long Island, and the other individual that the farthest of any of the birds went out to Delaware Bay, whereas the rest of the individuals are, for the most part, residing around Fisher's Island and that part of off the coast of Connecticut right now. So they haven't really dispersed very far at all. So there's an incredible amount of variation between individuals. We still haven't determined, we have feather samples to determine the gender of these individuals, but we don't have those data back yet. So I don't know if these are differences between males versus females. So I'm interested to see what the answer to that question is. So as we expected, and you're going to hear a lot about the tracking technology, but it's been fantastic. It's worked incredibly well. So we're hoping this technology will work for multiple years. As we've shown here, at least during their breeding season, they're typically foraging about 15 kilometers from the colonies. We found very little overlap in the movements between the adjacent colonies. And about 50% of those tag birds have dispersed far from their breeding colonies. But interesting to see if there's any late dispersal in January, February before they initiate breeding again next May. So we'll see. And our current plans are to track 10 margulls on Block Island this upcoming feedal seasons to get some more indication of movements in offshore areas where the wind farms are being constructed right now. So thank you.
All right, I think we probably have some time for questions, so have at it.
I'll ask a question, Juliet. This is Pam. I'm curious how often the gulls realize they can break the rubber bands around their bill.
I'll let Juliet answer that.
They weren't breaking them, but you have to get them pretty tight. And I'm always paranoid about remembering to take them off before you release the bird. But
oh, good point. Yeah.
Didn't have any issues with them breaking, but I think if we tried to use the same rubber band for too long, that would become a problem.
Yeah, and you definitely have to use them because they.
We started out with a hair tie because, yeah, the circumstances demanded, and then we upgraded to a rubber band.
They have incredibly short bills, so there can be a lot of blood if you're not careful.
Awesome. Awesome work.
We have a few notes in the chat that some of the patterns we observed are similar to ones from the Project WOW data, and we're definitely looking forward to kind of synthesizing all these data sets from different colonies that have obviously different sort of foraging patterns between colonies to see what kinds of patterns we can see.
Yeah.
Also a comment from David Baker about comparing monthly predictions and MDAT models to the tracking data, which is a good thought. Those are coming from survey data, obviously, and don't include kind of the individual movements over time, but would be interesting to see how the patterns compare to one.
Yeah, I mean, we just have, I mean, this data are still coming in, so we haven't had time to really dig into it yet, but those are great thoughts.
Caleb.
Yeah, great talk, Peter. I think you might have mentioned this, but how long are you expecting these tags to last? I mean, I'm assuming they're solar powered, and what has it's a big tag, so I imagine it's got a pretty good battery.
How long am I expecting, or how long am I hoping?
Well,
yeah, I
yeah,
don't know.
that's a
Do you
good
have a
point.
good idea?
They never last
for,
as long as the manufacturers say they will, but
well, and also the harness material and everything too.
Yeah.
So I'm hoping that, what would you say, Juliet, 2 to 3 years if we're lucky?
Yeah, hopefully. I mean, I don't have a lot. This is the first time that I've used the PathTrack GSM transmitters, so it's hard to, different manufacturers have different results, but I did a gull tracking project several years back in France where we're still getting data from birds that we put transmitters on back in 2021. So that's the same harness method, different transmitter type. So it's possible, but yeah, TBA.
That's cool.
I have a question from Liam. Liam, you want to ask your question, or do you want me to just read that out?
No, happy to. Hi, Peter. Is it possible, and if it's possible, do you plan on tagging any pre-breeding birds? I know at some colonies there's some like pre-definitive plumage birds with brown or maybe nearby the colony. Is it possible to capture and track any of those in blackbacks?
Well, I'll just be, it's a lot easier just to catch them on the nest. So our plans are just to do is that box trap to catch them on the nest. I mean, we could try other techniques, but I think for the purposes of what we're doing, we're probably just going to trap on the nest.
I'd say it would be really nice to be able to continue this work beyond the current project. And I think that's something that we're looking at, especially as more wind energy comes online, to kind of get some more information on like how they're reacting during different phases of development, especially since we're seeing these apparent attraction effects during the construction phase. So I think for future work, that's something that would be good to consider. But yeah, it is a lot easier to catch them when they're coming back to a nest site, when they're rather than when they're just hanging around on the rocks. So we'd have to adopt our very, very high-tech capture methods to be able to do that. Any more questions for Peter? Baited news carpet, says Ian. Yes, that was what I was thinking.
Yeah. I mean, we could do it. Yeah, yeah.
Joan says she assumes that the tags have a good altimeter. Wouldn't that be nice? But no, they just get GPS altitude. And every time I've talked to tag manufacturers, their answer is that you can't put a waterproof altimeter into a GPS transmitter. But maybe some of you who've also been having those conversations have had more luck with that. I know that's something that a lot of us are looking for. Dawn says a bonet. All right, Allison or Caleb, I'm not sure what schedule you want to stick to now that we're kind of off, but I could start now and then we could save the rest of the questions to the end.
Yeah, go for it, Juliet.
Okay, cool. Let me just do the sharing dance. Okay, is this looking good? I'll just assume.
Looks good.
Great.
Yeah.
All right. So we've heard a lot about gannets so far. I'm going to tell you some more about gannets. So we have in the New York Bight, which is kind of the focal area for the research I'll be talking about, we have kind of, we're sort of at the forefront of wind energy development, right? We have several wind energy areas that are currently being constructed and many others on the way, and we're moving into a new phase of wind energy planning. So there's a lot of activity in this area. And BOEM has kind of taken a regional scale approach to looking at effects of wind energy throughout the New York Bight, which is interesting and kind of new. And sorry, this is giving me weird stuff. Okay. Yes, there we go. And so we're trying to get a handle on what seabirds are doing in this area as we kind of move into this new phase of really regional scale wind energy development. And Northern Gannets, for reasons that have been mentioned sort of throughout the day, are really useful focal species for this kind of work, and also have some interesting kind of peculiarities, I guess, in North America compared to other seabirds, and also compared to gannets in other parts of their range. So gannets in North America are very concentrated in their breeding areas. They breed on only 6 colonies in Atlantic Canada, but during the non-breeding and migratory periods, they range throughout the Atlantic seaboard and into the Gulf of Mexico. And so unlike the areas where wind energy has been built in Europe, which are often very close to gannet breeding colonies, most of the gannets that are being affected by the current phase of wind energy development, at least in the New York Bight, are non-breeding and migratory birds that are passing through the area and or spending the winter in the area. So what do we know about gannets and offshore wind? We know that gannets are classified as a highly vulnerable species for a few different reasons. So this is coming from Julia Robinson-Wilmot and others' vulnerability analysis back in 2013. Gannets fell into the top 20% based on population vulnerability, the top 5% based on collision vulnerability, and the top 15% based on displacement vulnerability of all of the species included in that analysis. So they do appear to be kind of relatively sensitive on several different axes to the presence of offshore wind energy. And Kate mentioned the meta-analysis that we completed recently on displacement effects. So gannets are showing consistent negative effects based on surveys, pre- and post-construction surveys from European wind energy areas. We found that 50% of those, 56% of those studies actually showed a significant effect, displacement effect of offshore wind energy on gannets. And there was an average of a 70% reduction in use of those areas after construction. And in that same meta-analysis, we also found an apparent effect of time of year. So studies that were conducted either year-round or during the non-breeding season found stronger effects than during the breeding season only. So as I mentioned, gannets are present in the New York Bight during their migratory and wintering, during their non-breeding periods. And previous tracking work as part of Caleb and Ian and others, 2017 diving bird study through BOEM, found that especially New York Harbor, right there kind of in the middle of the New York Bight, is a really high use area where gannets are persistent throughout a lot of their non-breeding season and are at high risk of exposure and overlap with offshore wind energy areas. So in light of all this, we decided to do basically what amounts to a pilot gannet tracking study in New York Harbor to see if we could get some fine scale data with transmitters that can actually collect data at much finer spatial and temporal scales than that previous tracking study. So we used Ornitella T20 GPS GSM transmitters taped to the tail, as with the Project BOW study, attached with Tessa tape and cable ties. We tracked 10 individuals that we captured between November and March of 2023 and into 2024. And these transmitters collected locations every 10 to 30 minutes. The good thing about the Ornitella tags, since they're uploading to GSM, is that you can check on the battery life regularly, and you can actually upload new schedules to the tags. So if you see the battery life declining, you can reduce the transmission frequency. And we did end up having to do that with some of the birds, especially the ones that we captured in November, because of poor solar recharging during those months. So those are the kind of less frequent duty cycles. And we found that we were getting about 2 months of data from the transmitters, some more and some less. We didn't have the retention issues with the November birds that Project WOW was seeing, but we just didn't have a lot of birds around in November. So ended up capturing 3 of our birds in the winter and 7 in the spring. And so from the GPS track data, we just briefly, I'll go through sort of how we derive behaviors from those data. So we regularized the tracks in time using a crawl model, continuous time random walk model, and then used a hidden Markov model to characterize behavior based on 3 behavioral states. So resting would be drifting on water, because that's how gannets are resting when they're out at sea, is just drifting on the water. So it's not a stationary resting state, it's a moving resting state, but very regular and very slow, and very linear. Then we have foraging movements that involved short steps, but also tight turns. So not these linear movements, but a more tortuous movement. And then we have commuting movements that are long steps. So the bird is flying, they're moving quickly, and they're moving in a pretty straight line. And so you can see an example track there classified into those 3 behavioral states, where orange is the resting movements, blue is the foraging movements, and green are the longer distance commuting movements. So what we ended up with, as you can see from this colorful rainbow spaghetti map, we did get several of those spring birds. We were able to track them up to the breeding colonies, but just for the purpose of this talk, since I'm focusing on the New York Bight and wind energy overlap, I'm just going to focus on these kind of wintering movements before they started their spring migration. And so we have kind of a range of birds with a real concentration in New York Harbor, where we were tagging the birds, but also movements down along the coast and also along the Long Island coast. So in the winter, this is just an autocorrelated kernel density estimate for the 3 birds that we trapped in winter. We had 15% of our recorded locations overlapping lease areas, with the main sort of activity centers being in New York Harbor, and then also down along the southern coast of New Jersey and into the mouth of Delaware Bay. In the spring, we had a much lower overlap with lease areas, so only 0.4% of recorded locations were in wind lease areas. And the main activity center was again concentrated in New York Harbor, with an activity center in Delaware Bay, but further into the bay, so not at the mouth of the bay as in winter. So in terms of the individual variation between birds, we saw quite a bit of variation, as you could probably tell from the rainbow spaghetti. So we had some birds with no overlap whatsoever with wind energy lease areas. So that's an example of one bird that spent time in Delaware Bay, commuted back and forth to New York Harbor, but didn't actually fly through any wind lease areas because it was staying very close to the coast in all of its movements. We had birds that overlapped only when they were commuting and only when they were beginning kind of their migratory movements, like this bird that flew through the southern New England wind energy lease areas on its way to starting its spring migration out of New York Bight. And then we had birds that overlapped with wind energy areas during all 3 of their behavioral states. So that was half of the birds were using wind energy areas in all 3 states. Two birds didn't use wind energy areas at all, and 3 only during the commuting phase. And that red bird is the wind energy specialist, I'd almost say, that was detected in wind energy areas in 25% of its locations. And so that leads into the amount of overlap, which did vary between individuals and also between seasons. So you see individuals, there was that 25% as the highest, there was 0 as the lowest, and kind of everything in between. And there was an apparent variation with greater overlap during the winter than during the spring, but that 25% bird, which really was an outlier, was during winter. So that seasonal variation might be spurious if it's that one bird that's kind of driving that pattern. Looking into the activity budgets during the day, so we saw mainly foraging and commuting behavior during daylight hours from 6 in the morning to about 9 at night, which is what you'd expect as the birds are kind of gathering and resting on water during the night. We see kind of a little peak in commuting movements early in the day, and then they decline throughout the day, but no apparent peak in foraging activity, although a little bit more toward the end of the day than at the beginning of the day, but kind of consistent throughout the day. And being out on the water and observing gannets, you can see that they are kind of just flying around foraging. I think we saw more foraging aggregations toward the end of the day and more concentrated foraging, but they do kind of spread their foraging activity out throughout the day. So in terms of overlap by activity, so what are they doing when they're in the wind lease areas? We saw about 5% of the resting areas that we observed were in wind energy lease areas. About 1.3% of the foraging locations that we observed were in wind lease areas. and about 3.4% of the commuting locations. And you can see from these kernel density estimates that the commuting locations were occurring generally a little bit further offshore. Birds are just tending to be flying a little bit further offshore. When they're foraging, they tend to be a little bit more inshore. So there was kind of a bit lower amount of foraging activity that compared to commuting or resting activity. And then to break that down a little bit more, in both winter and spring, we saw lower than expected foraging activity inside compared to outside lease areas. In the winter, we saw more resting activity than expected. In the spring, it was pretty similar between inside and outside. And we saw opposite patterns for commuting. So in the winter, we saw less than expected commuting activity in the wind energy areas. And then in the spring, we saw greater than expected commuting activity. So just to look at kind of the individual lease area overlap a little bit closer. So Empire Wind, which is the closest lease area to our capture area in New York Harbor, we had 40% of the individuals who tracked using those areas and using them across all different behavioral states. So some individuals had core foraging areas that overlap directly with that kind of inner tip of Empire Wind, and some of them avoided it altogether. The southern New Jersey wind energy lease areas were also used by a few different birds. So we only had 2 birds that actually overlapped with those areas, but we had many birds that were regularly commuting up and down the New Jersey coast between New York Harbor and those foraging areas at the mouth of Delaware Bay and within Delaware Bay. So depending on how far offshore they were going, many of them were flying very close to those lease areas and not going into them. There's a lot of sort of potential for overlap in that shoreward side of the lease areas. We also saw use of the Delaware and Maryland offshore wind energy lease areas by one individual, that super user who had 25% of its locations in wind energy areas. And we had 4 of the 5 birds that we had northward migratory tracks from pass through at least one of the southern New England wind energy lease areas. So that does appear to be kind of a movement corridor for birds. Again, it says they're migrating out of this area up to Atlantic Canada for the breeding season. So looking ahead to future directions for this work, we do have accelerometry data from some of the transmitters when solar recharging was good enough. So we can use that to validate these hidden Markov metals, which seem to be doing pretty well, but it would be good to kind of have confirmation that the foraging behavior that the models are pulling out is really likely to be foraging behavior. And given that gannets are diving, their accelerometry data is very different when they're in a dive and they're kind of moving downwards versus moving horizontally. So that'll be a pretty easy thing to validate. We're looking to incorporate habitat variables into this, so not only to see why birds are where they are, but also when they're switching between states, so like switching from a commuting to a foraging state, that kind of gives you a sense of how they're selecting the habitats that they're using for foraging, how they're like queuing in on those habitats. So it'll be really interesting to look at how state switching behavior corresponds to environmental variables. We do have tissue samples as well, so blood and feather samples from these birds, and we're planning to look at health, stress, and potentially stable isotope content in those samples. And then to coordinate with the great work that's coming out of Project WOW from a little bit further to the east of where we're working, to get some regional scale sense of gannet habitat use and movements offshore. And in terms of long-term goals for this work, for wind energy development in particular, so New York, as I mentioned, is moving into a new phase of wind energy siting for further offshore. So understanding movements and if birds are ever likely to be located offshore, probably not necessarily for gannets, but other species that are moving offshore, is a good future direction for this kind of telemetry work and analysis. Looking at cumulative impacts, not only within the New York Bight, but as birds are moving out of the New York Bight through their migratory tracks. They're moving through the wind energy areas that may become lease areas in the future in the Gulf of Maine and into Canada. And so understanding the cumulative impacts is going to be really important, and something that's this kind of data can contribute to. Contributing to science and monitoring plans, for example, through Regional Wildlife Science Cooperative, and then looking at mitigation options. So we know kind of what to do on breeding colonies to make habitat better for birds in some cases, but understanding at-sea habitats and how we can improve those is still a data gap, especially during the non-breeding season. So hopefully we'll be able to contribute a little bit more understanding to that. And with that, I'd like to thank everyone who helped us out with fieldwork, and all the really nice photos that aren't necessarily mine mostly came from Brian Doherty, who takes great gannet photos. And you can always have like the New York skyline in the background when you're catching gannets in New York Harbor, which is quite exciting. So that's all I got. And I guess questions. Stephanie.
Can you hear me? Sorry, I don't know if my microphone's
Yes.
working. That was such a great talk. I'm so excited about so much of it. But I have a question that actually doesn't have to do with offshore wind. It has to do with my other interest on HPAI. And I was wondering if you had serum samples from those birds and were interested in knowing whether or not they had any indication of prior exposure to highly pathogenic avian influenza.
Sure, we do. Yeah.
All right. Okay. Well, we'll follow up. And if Diane is on this call, she might want to weigh in. But if not, we can chat because there's yeah, I'll follow up.
All right. Sounds good. And it looks like a question from Ian Jones as well. Do you want to come on and ask that, Ian, or should I just read it off?
Sure, I'll come on. I just was wondering, do you plan to measure this over a time span to make sure that it's your measurements from this particular year are representative? Because some seabirds can really change, what they do from one year to the next.
So two-part answer to that is this was intended to be a pilot study, so we're actively looking for funding to continue doing this, like kind of repeating this over years. But the problem with the tail tape attachment, obviously, is you only get a couple months of data from any given bird. So I'm really interested in the question of kind of like individual, stability and behavior and habitat use over time. And that's not something we can really answer with these data. And anecdotally, just, going out and capturing, it seems like there's some variability from year to year in how gannets are how and when gannets are occurring in this area. And so like we were expecting to see more birds in our first couple of years in November, and weren't seeing really aggregations until like later in the season, which could have to do with HPAI, which also corresponded to this time period, or it could have to do with kind of variation and not seeing as many small menhaden that they tend to be queuing in on in this area. So yeah, understanding kind of the individual level year-to-year variation would really require being able to attach a transmitter over multiple seasons, which I know has been a problem with gannets in the past because of their plunge diving behavior and because of the difficulty of attaching anything that's going to be interrupting that and making them sort of less mobile in the air and the water. And that kind of, I know, is an ongoing interest of a lot of people that are working on this species, to come up with a really good way of attaching transmitters that's not going to disrupt the bird and, have any negative effects on it.
Yeah, I was thinking more of population level changes in movement to location rather than individuals, although obviously I'm very interested in individuals as well.
Right.
But I mean, if you repeated the same experiment, annually for 20 years, you'd probably see some variation what they do. And that might be relevant to wind farm issues.
Yeah, that's definitely the goal. And we know that 1 year of data isn't necessarily representative. So hopefully we'll be able to continue this study beyond these first few years of kind of pilot work. Yes, Caleb.
Yeah, I know. I don't think the sample would be huge, but just getting at that question, looking at some of the diving bird study data, there were individuals that we got multiple migrations, not too many, but a few. Might be interesting to see how similar they were. Just looking at that variability. My question was about, I know that it was the sample size was 10, but was the Delaware Bay was the furthest south that you saw any of the birds go during any of the?
There was one
tracking?
bird that went further south, not quite all the way to Chesapeake Bay, but about halfway between Delaware Bay and Chesapeake Bay, and then just turned around and came back. But yeah, we didn't see any birds going down to Chesapeake Bay out of our sample.
Yeah, it's interesting. I just wonder if birds because that the birds that we tagged on the diving bird study were all tagged further south, if they are partitioned in their wintering areas. It'd be interesting to know.
Yeah,
whether
and looking
it's
at the
kind of,
WOW data, it looks like a lot of those birds from further east are just skipping right over New York Harbor and kind of going straight down. So there might be kind of, birds that are moving into New York Harbor are kind of staying in there a little bit more, and birds that are going past or, maybe only going up through that area during the spring migration or something like that.
yeah, and we even had some birds go a long way and then come back, like down to Florida. It was interesting. So yeah, it's I wonder if the birds in New York are just staying there, holding tight a little bit more.
Yeah, and
Certainly
these
in the
within winter
diving,
movements are super interesting because I think we underestimate those in a lot of seabirds. Like same with sea ducks, like they move around a lot during the winter and they often move back and forth through the same areas. So from a wind energy perspective, that's like a major source of potential exposure that might be overlooked otherwise. Kate, were you going to say something? Sorry.
oh, sorry. Yeah, well, I was just the diving bird study data, like a bunch of those birds. Granted, they were captured in the bays, like Chesapeake and Delaware Bay, so there might be like a capture location effect in there too. But as I recall, there were a good number of birds that tended to stay in those bays, and then you get a bunch of birds that do these big within season movements. And so I wonder if that's what you're seeing in New York Harbor too, like some proportion of birds just sort of chill where they are and don't move that much. And then you get a bunch that are at least sporadically moving quite a bit.
Yeah, with the caveat of small sample sizes, that definitely seemed to be the pattern. Some of them were very concentrated in New York Harbor and not moving much beyond that. And then some of them were kind of doing that pattern of moving down to Delaware Bay and coming back up pretty regularly.
Just putting a paper in the chat that might be relevant that you could check out from Bonaventure Island, one of the main colonies.
Cool. Check that. And yes, we do have some colony data that could be interesting to look at as well.
This is Doug Forcell. I seem to have lost my hand to raise. Can you hear me?
Yes, Doug, I can hear you.
Oh,
sorry, you lost your hand.
Well, I could reflect that when we were doing the radar studies at Avalon, a lot of gannets are going by in November. And so the ones that are going down to the Gulf and stuff are already down there. So if you're putting tags on in after molt and stuff, then you're probably getting sort of not resident, but the birds that are wintering in that area. In the
Yeah, that was really our goal, was to try to tag birds that would stick around for a while rather than just heading down south. Yeah. I guess if Peter wants to come back, if there are any last questions for the two of us on this session. What measures of stress and immune health are you planning on looking at, says Shana? You're thinking of corticosterone in feathers and blood, and then potentially just like an overall sort of health panel on the blood samples. But yes, happy to talk more if you have ideas. HL ratio too, which would be part of the health panel, but as a good kind of complementary measure of stress.
And if there's questions for anyone else, we still have 7 more minutes, so we could do a comprehensive if anyone has a lingering question and people are still around.
Everyone come back. I don't want to just look at myself. Come back.
Everyone turn on your camera. Make Juliet
Yay, I'm not so alone.
It's hard at the end of the meeting to just look at yourself and everyone's initials, isn't it?
Juliet, this is Doug again.
Yeah.
So maybe down in Costa Rica, I'll show you. I've got some radar images of at dusk watching the gannets all move offshore. And we always wondered where they went, because over the last half an hour or so before dusk, all the gannets left Avalon area and you could see them moving out to offshore. And I assume they got into some kind of flocks and got on the water and roosted, but I didn't have any idea how far off they went. So
yeah, I'm sure Julia and the other Project WOW folks could talk more about that. So they're doing their captures at night when the birds actually are in the rafting flocks, and they were going I want to say like 10 miles offshore, but
That was kind of my feeling. And that was one of the problems because they were planning on putting turbines in off New Jersey fairly close. And so the birds would be flying through them to go out to the roosts. And
yeah,
I don't know.
that's, I think, reflected also in the patterns we're seeing where there's less foraging activity than expected out in the wind energy areas, but either more or similar resting activity. And like the resting activity is probably when those birds are moving offshore and resting during the night.
Yeah, I'll just say we're not always going 10 miles offshore. Sometimes it could be closer.
Worst case scenario.
Yeah, so honestly, the boats we were using, we really wouldn't be wanting to be do that unless we were in really, really ideal conditions. This year we're using some bigger boats, so we might be able to get 10 miles offshore. I think it's certainly a limiting factor how far you can get offshore at night in challenging conditions, because we felt like they were rafting further ashore than we were kind of able to get to in a reasonable way. So more soon on that, I suppose. But yeah, it's they can get quite close to shore. I think you got to get lucky with the weather conditions though.
All right. I think everyone's done. So we can let everyone go home a little early unless someone else is going to jump in.
I was just going to say one thing.
Yep.
Thank you so much. I missed some of the talks, but I came in towards the end and really exciting stuff. I heard a little bit about what Stephanie said, asking you about even influenza samples. And I would just echo, Juliet, that, I mean, any information that could be put out there would be great. We would be more than happy to work with you, or, let's hear what Stephanie has in mind. Johanna raised the question, I think, about some of the other assays. So in general, we are looking to broaden the suite of information on the different species, especially if there's a way to look at disease questions in relation to movement ecology. But I don't know if Johanna is still there, and if you wanted to follow up briefly on your question about some of the other immune assays or transcriptomics. So we were trying to take a broad look, active infection, serology across time. Johanna at URI, Nicola Hill, who also works with Tufts, just trying to also learn a bit more about transcriptomics and if there are genetic markers that can help us understand the disease perspective, immune response more. So just depending on what people might be interested in, we would love to collaborate. There's also limits on what people are interested or willing to do as far as blood samples and other.
Yeah, no,
But
that's
happy
great.
to talk
And
more.
this was kind of the intention, is to develop a long-term study and including collaborators and axes that can sort of maximize the data that we're collecting while we're out there, and, give us complementary data streams to the movement data would be fantastic. So yes, let's talk more.
Yeah, so there's
Great.
a number of
Thanks.
immune assays that we're interested in running just to characterize overall health and characterize inflammatory responses, whether it's, disease or other stressors. So I think it could be really complementary to the movement data and kind of help broaden the picture.
Looks like Paul has a question.
I think, can you hear me? Yeah, you can hear me now. I did a Gannet study years ago down at the mouth of the Chesapeake, working from the Bay Bridge Tunnel when one was allowed to do that, when one could get access to that place. And gannets moved in and out of Chesapeake Bay very freely in pursuit of prey. And they were phobic with regard to structure. They all passed through those 2-mile-wide gaps that were underlain by the tunnels. They never crossed the trestles. I think this is totally germane with regard to gannets and offshore wind structures.
Interesting.
Yeah, it's an interesting observation for sure.
So anyone who wants to replicate, just go down to the Chesapeake Bay Bridge Tunnel during gannet season, and you will see this, that they just don't mess with the trestles. They go through those mile-wide gaps. And I've also wondered, maybe somebody knows about this, when they constructed a bridge out to Prince Edward Island across that big water course there, formerly gannets could go around Prince Edward Island in the course of their foraging. I don't know what their behavior is with regard to that bridge and its trestles. I think that's an interesting question for Canadian researchers.
All right. Any other questions? And I think we can maybe actually let everyone go.
Yeah.
Yep.
I just want to take a minute to thank everybody for being a part of the this Atlantic Marine Bird Cooperative meeting. It's been really great, and I also want to remind people that it's not completely over. We've got a presentation session tomorrow, another tracking session in the morning, and then at 11 o'clock is the Roseate Tern recovery group meeting. So please, that's open to all. So please join that. And again, it's just amazing to see all the work going on here on the Atlantic coast and the Marine Bird Cooperative area. It's a small but mighty group, I have to say. So, well done, everyone. And I will just a reminder that I will be posting notes and recordings, including the notes and the chats in the next month or month and a half. So thanks again, everyone. You guys are amazing, and we'll see you tomorrow, hopefully.
Yes, and we welcome everyone to join us at the Roseate Tern meeting. Even if you're not studying them, we welcome your thoughts. So please consider joining us throughout as much as you can for tomorrow. Thanks.
Thanks, everybody.
Love it, Allison. You guys did great. Thanks so much.
Back. Hi.
For 5 minutes.
That's good.
You want to hear something bizarre?
Sure.
So I had to jump on a Teams meeting that the link was created by, was it intra-agency, was the DWR, and I put on a presentation, and damn if it didn't advance. So I don't know what the deal is.
Oh no.
You know what I mean? It's like,
yeah.
What is going on?
Yeah.
Was it
Anyway.
was it another Teams meeting, Ruth?
Yeah, it was a Teams meeting, and it was one of my colleagues that set it up. So it was DWR, and yeah, it worked. So anyway,
I don't know. You weren't the only one, so don't worry.
I know. I hear you. Anyway, you guys go have a beer. You deserve it. See ya.
Thanks. Yes. So Allison, I will be there tomorrow, and however, let's stop the recording. Let's see, stop that. And
I got it.